各位贵宾，大家午安！欢迎您线上参与离岸风电竞争力高峰论坛活动，即将于5分钟后开始。提醒各位贵宾，登入后请于聊天 Chat 中留下您的公司名、姓名、职称。感谢您的配合，谢谢。各位贵宾，大家午安！感谢大家参与今天的台湾离岸风电竞争力高峰论坛。在活动开始前，有几件事情再请各位协助配合。为尊重智慧财产权，会议当中请各位不要录影及拍照。本论坛结束后会提供问卷的 QR code， 填写完问卷者2周后即可获得今日讲师授权简报之简报下载及今天论坛的影片连结，邀请大家协助填写。提供您宝贵的意见，谢谢。本次活动是由 SEMI 旗下的 GSA 绿能暨永续发展联盟主办，欧洲在台商务协会协办。另外，也要特别感谢支持及赞助单位东方风能、DNV、Mooreast 及天丰新能源。离岸风电发展势不可挡，台湾政府将离岸风电视为能源转型的关键支柱。2030年目标装置量达13.1 GW。2050年更是高达40到55 GW。本次论坛主轴将聚焦于建构离岸风电供应链竞争力，邀请到来自政府与全球离岸风电产业领导者的重磅讲师，分享最新政策与技术趋势，聚焦风电在地化与全球化的供应链合作。参与的专家们将深入探讨包括风机技术、船舶运输、系泊系统以及浮动式离岸风电的挑战和机遇，助力台湾在国际风电产业链中的竞争力提升。此论坛将提供一个专业的产业及技术交流平台，让产业领袖共同探讨当前市场趋势、技术创新，促进产业间的合作与技术共享。论坛的一开始，首先邀请 GSA 风能产业委员会的副主席，同时也是东方风能的执行长 陈柏霖执行长为我们致欢迎词，热烈欢迎执行长。
主持人你好。各位贵宾、专家学者，还有业界的同仁，大家午安，大家好。我是东方风能陈柏霖，非常荣幸今天能在此以副主席的身份代表 GESA 风能产业委员会来欢迎大家在线上参加本次的离岸风电竞争力高峰论坛。那同时也要跟各位抱歉说，我们今天需要临时改为线上的方式来进行本次论坛。但我相信今天来自各领域的重量级贵宾们会为大家带来非常精彩的一个分享。那如主持人刚刚所说的，随着全球对整个再生能源需求的一个增长，离岸风电在全球都成为未来能源转型的一个关键领域，而供应链的长期稳定性和竞争力将会是推动离岸风电产业持续发展的一个重要的保障。那也相信在台湾的各位现在都已经开始渐渐的感受到我们三陀台风带来的威力以及影响。那我想很多人都跟我一样深深的感受到计划赶不上变化的困难。但是透过这次的台风的影响，我想同时也让线上的各位理解到，在台湾海峡建置离岸风场是一个多么艰困的挑战。而在台湾建置离岸风场的这些开发商、供应商、施工厂商，甚至研究与设计各单位等等，都是在这样的一个艰困的环境下，去成功将台湾海峡的风机一支支的树立起来，并且通过层层的考验。这对整个产业都是一件非常了不起的成就。那所以在今天的论坛当中，我们很荣幸的邀请来自产业界的各领域的先进来跟我们分享，并深入探讨离岸风电供应链的优化。那今天的讲者阵容呢，包含了专注于推动台湾离岸风电及再生能源政策的能源署陈组长，以及来自学界的重量级人物江茂雄院长，以及其他来自整个产业各界的，如开发商天丰新能源、风机供应商西门子歌美颯、海事工程厂商东方风能，以及国际系泊和錨定专家的 Mooreast， 最后还有来自全球最知名的第三方验证机构 DNV 等各领域的领袖来跟我们共同探讨当前的一个离岸风电的政策及市场趋势。那更重要的是去讨论说现在在离岸风电整体上遇到的挑战和一个机遇。那我希望说能够透过这一次的论坛，能够促进整个产业间的合作以及技术的共享，那共同来建构离岸风电供应链的竞争力，并进一步去加速我们整个台湾离岸风电产业的发展。那希望今天的论坛能为大家带来新的视角和启发。感谢各位的参与，那让我们期待大家精彩的演说。谢谢。
谢谢陈副主席的致辞，谢谢您。Next, let's welcome Mr. Henry Zhang, the chair of European Chamber of Commerce Taiwan Low Carbon Initiative, to give us some remarks. Welcome.
谢谢。Good afternoon. 大家午安，大家好。ECCT 欧洲商会 has been part of Taiwan's energy transition in recent years. It's why it's very good to see that today's forum places an emphasis on the word competitiveness. It's worth noting that Taiwan's wind energy development started great with some slowing, and now both government and private industries are working hard to address potential solutions to the issues of localization, financing, permitting, and other issues. We also know that the pandemic brought impact on the supply chain, from components to manufacturing, from installation to maintenance. As ECCT, we try to bring the best of European technologies to Taiwan. And in Europe, we've had some success stories in addressing these issues by way of collaboration across the supply chain. For example, in Denmark and Germany, Strategic alliances have led to significant reduction in costs, increased efficiency, and showcased that these efforts not only improved project viability, but also created local jobs and stimulated the economy, reinforcing the social benefits of wind energy. And next on the horizon is floating and other emerging technologies. Once again, showing continued innovation will unlock the potential for harnessing wind power, including in regions with limited shallow coastal waters. So with competitiveness in mind, we look forward to more collaborations within the supply chain and exploration of emerging technologies that will shape a more sustainable future, while position wind energy as a key player in the transition to a low carbon economy in Taiwan. And with that, thank you all, 谢谢大家 for being here today. 谢谢.
Thank you, Chairman Zhang, for your remarks. Thank you. 接下来呢，我们要进行大合影的环节。我们邀请长官及讲师将您的视讯镜头开启，一起看向荧幕的镜头。Now we would like to invite all of our distinguished guests and speakers for a group photo. So our speakers, please turn on your camera and look at your webcam. We're going to take an online photo together. All right, let's wait for our speakers to turn on their camera. 好，请开启您的视讯镜头。All right, let's wait for a second. All right, now please look at your camera, your webcam in front. And 3, 2, 1, give us a big smile. And please remain your smile for about like 5 seconds. All right, one more. Smile again. All right, thank you very much for all your participation and cooperation. Thank you. 谢谢所有的长官及我们的讲者为我们的论坛留下一个美好的画面，谢谢。那么接下来就要正式的进入台湾离岸风电竞争力的高峰论坛，建构离岸风电供应链竞争力。让我们欢迎第一位讲师，经济部能源署陈崇宪组长，为我们分享台湾离岸风电发展政策与未来规划的主题。欢迎。好，请问我们陈崇宪组长有在线上吗？请开启您的视讯镜头，还有麦克风。
Okay. Do you hear the
有听到
voice?
声音了。
Okay.
Yes, we can hear your voice.
Okay. Thank you, Chair. I'm Chong Xian from the Energy Administration. It's my pleasure to have this opportunity to share some offshore wind market and also offshore wind policy in Taiwan. I think that today is Typhoon Day. It means that yes, Taiwan for the offshore wind energy, we must have some challenge, but because of the typhoon. But by the way, we also have some opportunity because of the wind potential is good enough. So, okay, based on this issue, I think I want to share some experience of Taiwan offshore wind market and also by the policies. First one, I want to share some market of the Taiwan, and based on these issues, first I want to share that the international offshore wind market, and based on this slide, you can know that yes, the offshore wind market is growing in the overall in the international market, and according to some prediction, I think that by the year of 2040, that will be over the 700 giga in the world. But if you separate into the detailed information, that maybe before the year of 2030, I think the bottom fields will be dominate all the market. And by the year of 2035, I think that okay, the bottom fields only about 96%, and the other one is about 40% of the so-called 14 technologies. And after the year of 2040, I think that 14 will be the other big potential for the international market. And by the way, I think the bottom fields market will be dominant about maybe the 19 or even the most part of the offshore market, because I think that at this moment the bottom fields the cost will be so clear compared to the 14 technologies. So based on this issue, so okay. By the way, we must do our so-called bottom fields market, but we also want to extend to pave the way for the so-called 14 technologies. And I want to share some information about the Taiwan adjustment of the offshore market in Taiwan. At this moment, we have over the 370 pieces of turbine at this moment. The overall in installed capacity was over the 3 giga. And by the way, I think according to the global wind energy councils, we are number 7 in the world. And maybe for this year, we have maybe the 6th or even 5 rank in the world. And from this slide, we can see that before the year of 2020s, I think that we so-called phase 1, we so-called demonstration phase. So it's before the year of 2020, that will be the phase 1. And before the year of 2025, we so-called that will be about the second phase. And after year of 2025, that will be the so-called zonal development, the third phase. And by the other issues that before the year of 2025, okay, the Taiwan government will use the feed-in tariff to support for all the offshore wind market. So after the year of 2025, we use the cooperative PPA, means now that all the developers they must to sign a PPA with some enterprise. So it means now that before the year of 2025, all the developers they just focus on how to cost down all the project, because I think the project will be separate into the cost and the price. And all the before the if the government uses the feed-in tariff, it means that all the developers they must pay their attention to cost down all the project. And by the way, after the we so-called the phase 2, we use the cooperative PPA, means that okay, they must to deal with the off-taker and try to get some good price. And by the way, they also want to cost down all the projects. So I think that it's totally different compared to the so-called the second phase. So by the way, you can see that the year of 2022 and the year of 2023, in that time, I think that I have the pandemic and also have some maybe some wars between the Russia and the Ukraine. So, but by the way, we still have some good installation capacity in that time. By the year of 2022, we have almost about 200 pieces of turbine in that time. And by the year of by year of 2023, we have all about the 300 turbines in the Taiwan. So it means that yes, based on the maybe the environmental is not so good, but for the Taiwan, we still have some good installation and good capacity installation in the Taiwan. And this slide, I think that almost all of you will know that this potential that yes, I think that Taiwan we have good potential about the offshore wind power. For the nearshore, I think that the water depth is below to the 20 meters. I think a feasible capacity will be about 1.2 giga. And maybe the deeper water means the water depth is less than the 50 meter. That will be about 10 giga. And the more deeper water means that there are more, the water depth is more than 50 meters. I think that we have bigger potential compared to the deep water. But at this moment, I think that we so-called the water depth below to the 50 meter. I think that it's about 11.2. I think that they have well planned that all the development they will focus on these regions. And by the way, we also for the deeper waters, we also have some site to have the also called bottom fix. But the other issue means that for the more water the depth, maybe we have some potential about the 14 technologies. So for this slide, we can show that for the Taiwan, we not only for the bottom fix, we maybe have some big potential for the 14 technologies. So yes, the government will pay more attention on the so-called bottom fix project. But by the way, we also put some efforts into the so-called bottom 14 technologies. I think that for the Taiwan's experience about bottom fix project, by the year of 2012, we start our demo with so-called phase 1. Means that okay, we don't have such experience like the regulation, like the technology validation. So we started our project by the year of 2025. But at this moment, just mentioned now, we are number 7 in the world. Means that the bottom fix, the environmental will be commercial, will be measures. So maybe the government will maybe follow our successful of the so-called bottom fix experience. We can put into some efforts on the so-called bottom 14 technologies. So I think that the Taiwan government want to pay more attention about 14 technologies. So by the way, for the Taiwan, we have the clear picture for the offshore wind energies. I think our target by year of 2050 will be about 40 to the 55 giga in that time. But you know that for the year of 2035 will be about 20 gigas. So maybe we not only need about the so-called bottom fix project, but also need some kind of the so-called 14 technology. I think that we can reach for the target by year of 2050. And for this slide, I just mentioned that for the phase 1, we are starting in year of 2012. And yes, we have completed all the project by year of 2021. And based on this successful experience of the so-called demo phase, we are going to the second phase. Second phase will be by selection and also by the auction. And at that time, I think that the potential candidate will be about 10 giga in that time. But you know that our target by the year of 2025 will be about 5.5 giga in that time. So it means now that 50% will win the game, and the other 50 will fail the game. And by the way, we are going to so-called third phase. Third phase, I think we are complete about 3.1, even for the 3.2. And maybe we have some issue, maybe the WTO issue, but I think we will follow the way with a stable and go to our target by year of 2035, even year of 2050s. And by the way, I think at this moment, we have the 6th commercial wind farm in Taiwan. I think the first one will be the year of 2019. I think the Formosa one will be the successful milestone for the Taiwan offshore wind market. And by the way, I want to share that, okay, for this years, we have 3 commercial wind farms in Taiwan. The big one will be the Great Zhanghua. They are over the 100 turbines in the Taiwan Strait. And the other one will be the Zhangfang, Xida, even the Zhongnen. Yes, they got all the project on time. I think it's a good milestone for the Taiwan. Every project will be great connection on time. And by the way, I want to share some future plan of the offshore wind market. It's some kind of we so-called challenge of the Taiwan. but also for some opportunity for the Taiwan. You know that for the Taiwan, we have big enterprise. They need some green power to follow all the international regulation that IE 100, even for some Apple supply chain or Google supply chain. Maybe I think the year is not in the so-called year of 2030 by the 30%, but there may be more aggressive target. Maybe the 27 for the 40% of the renewable energy. So yes, Taiwan really need some power from the offshore wind power. So, but we still have some we so-called challenge for the phase 3 project. I think all the project they have some issue like the cost. If you separate into the cost and the price, the cost will be rather. I think the first issue is about the imbalance about the supply chain and demand side means that the CapEx will be maybe a little rise compared to the phase 2. So there will be the CapEx will be higher compared to the second phase. The other issue is that maybe the interest rate will be higher compared to the second phase. And they also need some local bank to support all the project financing, because I think that maybe some project, especially some ECA, the export credit agency, they support all the project, but they also need some local bank to support all the project financing, especially for the state-owned bank. The other issue is means that the price issues. Okay, all the project they will be about they need the long-term contracts. The other issue is that the high international rating, especially some company. Okay, they have good profit in the near years, recent years, but the international rating is not so good compared to some company. So maybe it's not good, easy to buy the power from the offshore wind energies. And the other challenge for the offshore energy will be about they must have some minimum amount of the power. So yes, for the cost side and the price side, yes, we still have some challenge. But you know that for this side means that the government want to help all the project will be great on time. So yes, based on the cost and the price, we have some action, we have some measures. First, about the cost, I think that we will review all the government fees, especially some charge. Maybe we can have a discount or postpone about 2 or some years. Try to cost down the project in an early stage, in the initial stage. The other one is not just mention that this needs some state-owned bank to participate for the project finance, because it means that the government will support for the offshore wind policies. So by the way, we think that yes, we will encourage all the state-owned bank to have some support, to have some finance about some project. So for the cost side, yes, we will try to review all the costs, but we will do our best. Means that if the government fees, we can have discount or something. We will try our best. The other one is try to have some so-called financial issues. I think a private-owned bank, they have active in the project financing in the offshore market, but try to have more state-owned bank to join the project. And for the other issues, especially for the price issues, yes, I think that with the international rating, the high international rating is not so many common in Taiwan. So we have 2 directions. First will be about maybe some big enterprise. They really want to buy some green power from the offshore wind energy. So how to help they can get it with so-called international rule, especially for the international rating. So for the Taiwan government, we will try to have the so-called CPPA credit guarantee mechanism. We are trying to, I think the government, some government funding, we are trying to guarantee the company maybe for the short time, they doesn't have a good international rating. So we are trying to do maybe the guarantee about this. Means not maybe if more company they can to buy the power from the offshore energy, the price will be high compared to the normals. And so okay, we have the also called credit guarantee mechanism to support all the issues. The other one, that Taiwan, we are have so many we so-called small and medium enterprise, but they really want to follow the international regulation or the rules. But it's not easy for some small and medium enterprise to buy the power from the offshore energy because they have some minimum amount of the power. So yes, the government want to organize with so-called a company, with so-called a green power retail company. They are organized by the Taiwan CPC, even the Taiwan CSC, Taiwan Steel companies. Okay, they will be just like the aggregator. They can buy the power from the developers and sell the green power to the small and medium price. So they are the some. It's good for the some small and medium enterprise. They can gather some green power from the offshore energy. So it's some kind of the government want to try to balance between the cost and the price to, especially for the bottom fixed project. Not only for the 3.1, maybe for the 3.2, even the 3.3. And by the way, we still need some based on the so-called successful experience about bottom fixed project by the year of 2012. Yes, we are trying to start with so-called 14 pre-commercial project. I think we just announced some draft in this early years, and we are trying to announce all the detailed mechanism for the so-called 14 offshore wind pre-commercial demonstration. And I think the commissioner years, I think for the early draft will be the year of 2025, but all the development, maybe they think that we can extend 2 years to the year of 2030s. But why the government want to so-called have the pre-commercial 14 project? Because I think that we want the so-called commercial project in Taiwan, based not only for because we want to reach for the zero emission target by the year of 2050. The target by that way in that year for the 14 technology will be about 40 to the 55 gigas. So I think I want some information about the so-called pre-commercial project will be about. I think that we are about 6 to the 12 quarter for the single application. Means now that the single application will be about 90 mega to the 180 mega for the single application. And the case will be the 2+1. Means the two cases will be the so-called principal. But if the some case is good enough, I think that we are seeing that okay, we want to have more demo, we want to have more validation project in Taiwan, maybe the different technology or the different marine technology or something. So yes, 2+1 will be our project. And by the way, the qualification will be that they must have the so-called EIA, and the review item will be separate to the technology and the financial, even if maybe they can have the domestic cooperation with our academic or some research institute. So I think yes, just mentioned that we have some challenge and opportunity for the 14 technology. So all the development they will be concerned about a bankable project. I think that the government also want to have the so-called regulation for the pre-commercial, not only for the pre-commercial, but also for the commercial project. And in fact, it means that, okay, the key or even the port want to have a more detailed spec about the key or the port, even for the grid connection issues. It means not, okay, you want to have the bankable project. The government incentive is important for the early stage, even for the pre-commercial project. And the technology, I know that in Taiwan we have a typhoon, so maybe we want to verify all the different kind of technology and try to find some good solution, good technology for the Taiwan. Finally, I have some conclusion. Yes, based on the so-called bottom phase project, yes, it's based on the public and private partnership between all the company from the European, from the United States, even from the other Asia countries. So yes, based on this cooperation for the bottom phase project, I think that we want to reach for the target by the year of 2050. And the green energy is the core of the Taiwan, especially the enterprise in Taiwan. They really need some green energy from the offshore energy. So we want to cooperate with all the global partnership to achieve the target. Thank you.
Thank you very
all my
much, Director
presentation. Thank
Chen.
you.
Thank you, Director Chen, for your insightful presentation. 接下来第二位讲师，我们要欢迎的是国立台湾大学工学院的江茂雄院长，他将与我们分享的主题是离岸风电未来的发展趋势。欢迎江院长。
OK， 呀，可以听到我声音吗？
可以听得到。
OK。Okay, good afternoon, ladies and gentlemen. In considering the local audience, we have several hundred audience online. So I would like to make my following presentation in Mandarin. I beg your pardon and understanding. 好，各位午安。好，那我希望在这20分钟的那个演讲里面我希望这个未来可以在 YouTube 上面有更多人来分享，所以我今天我会以中文的方式来介绍，就是说离岸风电未来的一些发展趋势。那这里面因为我有参与在政府的智库里面这个所谓的台湾近邻科技推动小组那我负责是前瞻及永续能源这一块的召集人，所以我们也在协助政府进行这些相关政策的一个研拟跟规划。好，那我想我今天的演讲主要是针对几个部分，一个是全球还有我们国内现在的发展现况。刚刚我想陈组长那边已经有一些把政策面已经做介绍，所以这边我就会很快的做一个简介。然后从这边来看到就是说我们在国内的我想这次的主题 supply chain 供应链的部分，离岸风电的供应链部分现在我们接下来要往前走有哪些需要克服的一些问题还有我们现在的成果有哪些我想我也会做一个很做一个 summary。然后接下来就是技术面的技术面的一些发展线的一个 summary， 然后还有我会针对其中的几点来进行介绍。然后产业的发展不能没有人才所以人才培育的部分那我也会做一个简短的介绍，最后一个结论那首先我们来看一下这个是 GWEC 最新的一个 report， 我们都可以看到就是说全球的整个趋势这个发展的是离岸风电的话是在这蓝色的这一块事实上是发展的在2023年大概 10.8 个 gigawatt。那这 10.8 个 gigawatt 里面我们可以看到我们台湾其实在2023年的新增的容量里面我们占了 6%， 我们贡献了 6%。 如果以单年度来看的话，我们在全球排名的话是第4。那刚刚陈总宪组长的简报里面可以看到，我们在目前累积容量我们大概是全球第7现在全球累积的话是 75.2， 我们现在大概3个 gigawatt。我想这个整个趋势是非常非常清楚的所以我们可以再从这张图可以看到，就是说全球预估到这个整个的成长大概每年大概是以 9% 的这个成长的比例就全球的就是的风电的市场那我们可以看到从2023年2024年对，然后到2028年大概是一年2028年一年大概就有37个 gigawatt。 那特别是在亚太地区是未来的一个重点所以我们可以看到就是说在俄乌战争还有现在近邻的一个那个要求底下我们可以看到就是说欧洲的这几个风电大国包括荷兰、德国法国英国等等，他们原来的目标的装置容量从到 后来的新的装置容量大概都是倍增加了1倍。那另外一个是我们亚太地区的，像台湾，我们台湾的话，在2035年大概20个 GW， 但是2040、50以后，我们可能会到40到50个 GW 更大。那韩国呢，目标是12，日本是10，但是他们目前其实都还是有第一个100 MW 的，像韩国现在是有第一个100 MW 的一个离岸风场建制，在今年要完成。所以事实上都还是非常的慢，但是我们可以看到，就是说这个整个的市场的在2026年以后，甚至2026到2030，全球事实上是这个离岸风电的市场是大爆发因为大家都在抢盖。那我这里还没有把美国给放进去，如果把美国的市场也放进去的话，我相信可以各位可以预期得到。那我们这个可以看到，就是说第2阶段的我们现在已经完成的就是说左边的这边这个是我们临显的风场。目前大概只剩下2个风场还没有完工大概我们等一下下一场是允能的风场，大概今年10月好像也要完工了那是剩下2个，一个是台电2期的，还有海龙2号的风场，这个还在建制，其他的都已经完成，所以我们目前已经完成了大概 3.01 GW， 我们有370只的风机已经在运转发电当中所以我想这个是我们目前非常好的一个成果这是在现阶段我们在全世界的排名上面也可以排到第7名。那接下来我们要进行的第3阶段第3轮，这个其实就会延续到我等一下要讲的几个重点就是说第3阶段第3轮的遴选对就是竞价的风场里面这些 auction 的风场里面有哪些技术是要马上面对的我想这个是可以接下来我要强调的几个重点。所以我们先来看一下供应链那离岸风电供应链因为我们建构一个有竞争力的供应链。那第一个供应链的话，当然是 supply chain 要 localization， 就是在地化。在地化当然可以降低成本，这个事实上这个就是我们目前在第2阶段所做的这些趸购电价的政策，用趸购的方式然后来发展我们在地的供应链，这个我们已经做了，所以我们有这样的一个政策在支持，所以我们供应链才会有现在的一些成果然后还有这些 cluster development， 这个就是我们现在像在台中港还有台北港高雄港等等这些的产业聚落也形成了。然后另外一个要增强竞争力的话，就当然要改善它的 logistic 还有infrastructure。所以我们的港部事实上大家也正在非常关心就是说我们台中港事实上是不够用的，那台北港这边也还要再增加空间所以这些的这个规划都需要及早的规划，尤其是未来浮动式的离岸风力发电来发展的话，那个更需要更多的一些空间。然后还有需不需要一些特殊船舶，还有更有效的这些运输还有储存的方式在港口码头等等。那另外一个是那个在 innovation and technology advancement， 就是说有一些新的技术，这些新的技术可以导入像比如说 AI。跟我们未来 O&M 可以结合在一起，就 digitalization， 这个等一下我在技术面那边我还会再来讲所以这边我稍微先简单，还有这些制程的优化然后自动化的优化，还有浮动式的技术，浮动式的技术我等一下也会单独来讲。还有我们整个人才人力的需求，我们各位了解我们在整个产业发展的过程当中，我们其实这些专业的人力是相当不足的，所以我们才会进行这些相关的人才培育我想这个等一下我也会详细的来讲那另外一个我们也经过这些 learning curve 了我想在过去的几年里面，我们国内的供应链好不容易建立起来的产能这个都是经过这些学习曲线，但是接下来如何去 cost down cost down reduction 这个也是更进一步我们要去进一步谈这个学习的，那这样子才可以跟国际的市场去做竞争。那另外一个很重要一个就是数位化这个数位转型我想这个是大家现在在讲的，包含在我们的离岸风电里面也是一样所以像 smart supply chain management 这些等等，还有甚至预测式的这些维护，这些相关的技术的话，事实上都是现在而且刚好可以跟我们国内强项是这个 IoT 的技术所以可以跟我们国内的电子电机的这些相关的产业可以互相结合在一起。那另外一个很重要的是政府的政策，我们在过去这几年因为我们有非常明确的政府的政策在 support 我们整个 supply chain， 所以我们 supply chain 才有现在的成果。那接下来我们当然希望政府能够继续再延续这样的一个让我们好不容易发展起来的这个供应链的话，能够继续的再发展下去。好，那很快的看一下我们现在的成果，这个各位也了解，这个就是我们第2阶段的这26个项目的所谓的localization 的项目这个产业关联的项目那这个确实我们已经有一些成果。那我们的整个产业的聚落在台北、台中、高雄这3个主要的聚落，事实上已经有相关的这些产业都已经成型了。那海事工程的部分，我们国内因为海事工程需要的投资相当大，但是我们国内也有像我们刚东方风能那还有台转环海等等，这个都已经是从在离岸风电发展以后慢慢的那个成型的一个新的一个产业那也慢慢的在茁壮当中。那另外一个是我们国内的这些相关的那个 supply chain Tier 1、Tier 2的 supply chain， 我想这个都是我们现有的一些成果所以像我们可以看到现有的一些成果像世纪风电然后还有我们新南海基等等这个也是世纪风电的我想这个都是我们的目前的一个非常重要的成果。那西门 SGRE 他们在台中港的机场组装厂那现在也今年5月我也去拜访去参访他们14 mega 的整个组装线也完成。等一下我想后面有SGRE 的那个经理高阶主管来做介绍。那这个我想这个是对我们来讲也是更重要的一个成果，就变成亚太的14 mega 的那个风机的供应链中心那还有叶片像天地的叶片等等我想然后还台转环海的这个那个我们的浮动式的安装船水下基础的安装船。所以我们整个来看就是说我们以现阶段以我刚刚所 summary 的那些来看我们现阶段的成果其实我们可以发现就是说还好我们当时的政策是正确的那而且是我们已经建构了这些这个供应链已经建立起来那我们等于是我们有一些自主供应的能力。那2026甚至2030以后，整个全球的供应链那个其实大家都在抢那没有这些包含像安装船也是一样。如果说我们当时没有去没有去建造比如说 Green Jet 的这艘安装船风机安装那个水下基础安装船，但是未来我们可能也要去跟国际市场去抢船所以供应链要抢，反正也要抢，其实人才也要抢这个人才我等一下在下一个主题我会讲。那接下来我们来看一下这个整个技术的发展的趋势我也是先把它做一个 summary。整个 Offshore Wind Power 它的整个在 technology 的这个领域它的整个趋势到底在哪里，有哪些还会继续发展下去。第一个在 Wind Turbine 上面就是说更大而且更有效率的 Wind Turbine 就是说我们可以看到现在14、15 MW， 接下来的话有可能到16到20 MW 但是呢这个其实还有一些可以跟我们下一个议题，比如说我们下一个议题就是 floating 浮式风电的这个风机这两个可以 cover 在一起来讨论就是说在浮式风机里面所使用的那个风力发电机跟我们固定式的这种风力发电机是不是要一样，是不是需要再去重新设计一个新的那个发电机的系统那另外一个问题就是说在浮动式的风力发电机里面，因为它是会晃动的，所以是不是越大越好15甚至20是不是最佳的选择。我想这个都还有很多未知的东西就是还需要进一步的去深入的去讨论。那这个就是这个第二个，像比如说 higher hub height我们在机舱的高度越高越好，这个在固定式的是如此，可是在浮动式的可能就不是如此，因为浮动式的你越高你浮台晃动就会越厉害，那浮台越晃动又会影响到你的发电功率还有疲劳整个结构的疲劳等等我想这个都是不同的思考方式，这个都需要更进一步的去讨论去研究所以在浮动式的这边的话，因为往深水区去所以浮动式的是一个这样，所以在深水区60、70公尺以上的那个你就算用固定式的，你的成本也不会低，因为到那个深水区大家那个成本其实就是会比较高。 所以浮动式的 maybe 是一个那个比较好的一个选项所以这个我想这个那浮动式的现在因为技术也还没有很成熟，所以大家都还在发展当中所以我想这个也是我们台湾现在还有的机会所以你不能用现在的阶段去算这个成本因为现在这个成本当然是相对是比较高的。OK 好呀，所以这个就是牵涉到量产所以你一旦成熟量产以后，你 cost 当然会降下来。那时候再来比现在固定式的那个 bottom fix 的那个 offshore wind 的话，这个才是合理的。OK， 那另外一个跟其他的能源的结合在一起，比如说跟绿氢的结合，我们最近也在规划，比如说在台中港或者是西南港那边把离岸风电跟氢能的结合在一起我想这个我等一下也会做更深入的介绍。然后还有这些 grid 这个电网的问题这电网问题，还有那个永续循环材料的再利用然后还有data driven 的运法，这个就是把 AI 导入到我们，还有 machine learning 的导入到我们的整个风场的运维里面还有这些无人的无人机还有水下载具这些的应用在我们的风场的。OK 好，我想这个都是几个那个好，那我们把整个在 focus 范围小一点，针对浮动式的风机来很快的看一下。浮动式的风场到现在大概全世界大概都还是在小规模的这些像比如说Highwind Scala 这个在欧洲的2017年它的那个过去的运转的这些 record 事实上对我们来讲是非常的那个兴奋因为它甚至 capacity factor 容量因子可以到57就54所以比那个固定式的要来得高，因为它离岸可能比较远另外一个在 Kincardine 这边的话这个在英国的苏格兰的这个也是一样所以大概都是50 mega 左右的一个那个示范案所以这个也是我们在想，就是说我们国内到底接下来我们国内现在大概都知道 TRL4 了那刚刚所看到欧洲这个案子大概都 TRL8 到9就是 TRL 就是我们所谓的技术成熟度所以以这样来看的话那我们去 summary 一下在国际上的几个重要的一个这个是浮式风机的计划那可以看到就是说那在这些国家除了欧洲国家，日本其实他们很早在做，但是日本这几个案子除了九州之外，大概其他的大概都是后来都是失败那中国大陆现在也在急起直追那我们台湾呢，我们需不需要自己因为我们自己风场的需求，我们那台湾有台风有地震这些的考量。那在固定式的话，因为欧洲已经发展的比较早，所以他们技术比较成熟。但是在浮动式的基础水下基础这种浮台的技术，全世界现在大家都还在发展当中。所以换句话说，大家都还有机会。我想台湾也是一样所以我们不应该是缺席。所以我们在国科会的那个计划底下在过去2年，我们发展了一个15 MW 的一个平台的一个我们把它称为台大浮台台大浮台因为时间关系我就很快带一下。那这个在 YouTube 上面也可以找到这个你可以在 YouTube 上看。所以我们设计了一个新的一个浮台针对台湾还有制造端还有我们的环境端来做这些相关的设计OK 所以这个其实是我们在跟台船还有那个一起合作的一个计划，把这个发展出来。那下一步呢，我们台湾下一步要怎么走？sorry。所以我们下一步要怎么走？所以这个浮台发展出来以后，事实上只是一个原型的设计，还有水槽那个缩尺的实验。所以这个是15 mega 的一个整个风机的连同风机15 mega 风机整个系统的分析所以这个我们都已经建立起来这些相关的技术那我们也做它比如说后面尾流的这些分析，这个在团队里面还有东台海缆的一些分析，还有水槽的实验这个是在我们台大的水槽里面去做这些100%的缩尺的水槽实验。那这些大概都是到我们所谓的技术成熟度4而已所以在这个之前其实我们在浮动式风机上面，我们也针对现有的像 Unreal 5 mega 的风机加上 OC4 的浮台，然后10 mega IEA 的10 mega 的风机，加上Live 50 Overplus 的 All Star 的那个浮台 然后再来是 IEA 15 mega 加上美国缅因大学的 UMain 的浮台那这个我们都做过。然后最后呢，我们去做说辞因为我们考虑未来有没有可能在台湾去做 TRL 5到7，单一机组比较小这个是2 mega 的那我们重新去设计这个浮台的大小去 fit 它。那这个是以 N6 mega 的风机去搭载我们自己设计的一个浮台的整个动态的特性所以你可以看到，就是说，事实上我们花了相当多的时间去做这些不同的排列组合。未来不管是开发商那边，或者是我们国内，我们可以自己设计，或开发商有现有的浮台现有的风机，我们都可以做这些排列组合去做这些进一步的分析，然后把台湾的风场的条件把它带进去。比如说台风现在台风正来那我们就可以把这个台风的风况带进去，看看会不会产生什么样的问题这个可以降低risk 我想这个是未来整个在大规模开发的 risk 就可以降低所以事实上我们团队也在我也在推动希望能够有一个 TRL 5到7的一个pilot project 但是这个事实上需要大概10亿台币左右单一机组，这个现在目前其实还是相当困难所以刚刚陈组长那边有提到这个福士的示范计划大概是6到12个机组OK， 那另外一个议题我很快带一下，就是我们所谓的复合式海域能源，就是说在离岸风场上面，我们想到的就是在离岸风场上面，我们在有没有可能再增加它的发电密度比如说在欧洲已经有几个风场，像这个在风场上面跟floating 的 solar PV 结合在一起，增加整个海域的发电量我想这个就是所谓的复合式海域的观念，甚至可以把那个波浪能如果说波浪能未来成熟的话，也可以加进来，那共用海底电缆那这样子的话就可以增加整个发电的密度我想这个未来这个在欧洲已经有几个示范计划，这个我们也在考量当中就是说有没有可能在台湾的离岸风场上面来实现最后那个人才培育的部分我就很快带一下因为产业发展不能没有人才所以这个有白领跟绿领的部分，所以我们现在有一个计划，就是刚好跟我们台大有一个离岸风电学程那这个离岸风电学程，我们现在刚好有一个教育部的很重要的离岸风电的最重要的离岸风电产业人才培育计划，所以我们未来会在台大那个建置这些培训的基地那我们跟建国科大台北城市科技大学、福伟科大、启义科大还有高雄科大结合在一起就结合白领跟绿领。那欧洲商会也是会还有 ECT 也是我们非常重要的一个 partner 所以我们这个培训的基地会在台北在我们的校总区这边会建置一个培训基地，现在正在建置当中。那第二个培训基地是在我们云林校区，我们会建置一个测试风机在这边做这些让学生可以实际的动手操作培训所以这个是我们在今年办了2场的中职师资培训离岸风电的中职师培训跟 ECT 所合作的OK 我想这个就是我想那我们在这些人培也跟国际上面像丹麦还有我们邀请很多的开发商然后风电厂商等等我们跟荷兰政府也曾经有一个中职师资培训的计划我想这个是大概是我今天的那个我们可以看到就是说在2030年全世界大概有3倍的量要去建置那不管在供应链上面可以看到3倍的，然后我们怎么样去扶植我们国内的供应链，甚至可以除了国内的市场之外，还可以去竞争国际这个3倍量的那个离岸风电的需求我想这个是大家可以拭目以待。好，我想时间的关系，我今天的报告到这边。好，谢谢大家。
感谢张院长带来精彩丰富的内容分享，谢谢您。紧接着，让我们欢迎今天第3位讲者，天丰新能源亚太区 EPC 管理副总监王中杰，他将与我们分享突破技术与专案管理的挑战，云林离岸风场的永续历程。欢迎王中杰副总监。
Hello everyone. For those non-Chinese speakers, sorry that my presentation will be in Mandarin Chinese. But the slides will be fully in English. So in case you have any question, you can ask me after. You can contact me after the meeting. OK， 好，那我现在开始今天的分享。
可以帮我们分享您的简报画面吗？
好的。
现在是听得到您的声音有简报出现了，谢谢。
好，各位长官，还有学界跟业界的先进，大家好，很高兴很荣幸代表天丰新能源 跟各位分享云林离岸风场突破困境的历程，那以及我们天丰新能源身为一个开发商如何在人才培育上提升我们的产业竞争力。那如同各位所知，云林风场我们遭遇了许多的困难，遭遇了许多困境，但我们确实在2023跟20242年去翻转了这个困境，去突破了我们的现况。好，那大家都知道，目前我们现在在被台风侵袭当中，但是在台风来临之前，云林风场已经完成了全部80座风机的78座。那事实上，剩下的最后78跟79两座也已经在我们的安装船在二层上。也就是说，台风如果没有来的话，那今天我们本来预期是可以以80只风机全数完工的状态，能跟各位报告这个好消息。不过，在我相信这场完成离开之后，我们会尽快的去完成我们的风场。那同时呢，也让大家知道说，我们目前已经加入运转的风机，已经超过530 МW， 事实上已经在台湾已经商转的风场里面也算是名列前茅。好。那今天我的分享主要分为3个部分，第一个部分是介绍 Skyborn 这家公司，第二部分是介绍云林离岸风场，第3个是有关于我们2023、2024 2年的突破困境的一个计划，以及如何突破困境的一个过程。好，首先关于 Skyborn 这家公司呢，我们是就是国际的资产投资公司 GIP Global Infrastructure Partner 的子公司。那包含前身的 WPD Offshore 在内，我们目前已经有超过20年的经验。我们的总部在德国的汉堡，全球大概有400位以上的同仁。那目前我们在建跟营运中的风场总有8座。那目前也是pipeline 全球的 pipeline 达到了30 GW。好，那在我们公司的挑战跟愿景方面，我们相信未来。我们需要给下一代的是一个能够近邻提供洁净能源的一个环境，这也是我们生产离岸风电给政府、给社区、给企业的一个目的。好，那在开始介绍 Skyborn 台湾之前，我想引用一句马丁路德金恩博士的一句话，他说，在衡量一个人的最终方式，并不是在他处在一个舒服与方便的环境中，而是在他处在一个困难与困境的一个状态。那我想这个是对 Skyborn 所有的同仁目前最好的一个写照。我们 Skyborn 台湾呢，在很早以前就被总部设定为是亚太区域的离岸风电人才库。那至今为止，台湾总共只有4家开发商是从头到尾参与离岸风场的所有的生命周期，而 Skyborn 是其中一位。那在云林风场完工之后，我们将拥有640 МW 的售电容量。那更难能可贵的是，我们 Skyborn 台湾拥有100位正职的正式员工。好，那这个在开发商里面其实算是相当多的，而且我们不是只有单一的方选，我们所有的100位正职员工，包含了开发，包含了投资人与利害关系的管理，包含了财务、法务、商务。还有包含施工设计，包含 engineering 设计，包含 EPC 的管理，还有 P&O 以及 O&M， 以及所有很多我没有提到的部分。好，那关于云林风场的部分呢？云林风场是台湾其中一个最大型的离岸风场。那我们总共有80只西门子制造的风机，那每一只是8 МW。那其中包含了50%是50%的 tower 是由台湾厂商 CS Wind 制造。那我们的变电站的厂商是 GE， 然后我们 cable 的 EPC 厂商是 Seaway 7。那这其中包含了 cable supply 由 LS Cable、韩国的 LS Cable 以及日本的 Sumitomo 所提供的海缆。那 foundation 的部分呢比较特别，我们是 multi contract， 除了我们的 supplier 有Steelwind 以及台湾的台塑重工，那 transition piece 的部分有 Smuder 以及俊鼎。那我们的船的厂商包含了有 NNDC、Fly Ocean、Jumbo， 还有 Boskalis， 还有logistic 的厂商盲目，组成了我们 foundation 团队。那在财务部分呢，我们有23家本土与国际的投资银行以及3个 ECA 来支持我们。好，那在云林离岸风场完工之后呢，我们每一年预计可以贡献的 状况是2400 GWh， 这大概相当于是24亿度的电。那我们可以支持大约60万家户的用电量。那减碳的部分呢，有120万吨的减碳量，这个减碳量相当于3100座大安森林公园的减碳当量。好，那接下来我们进行到这次的重点，就是云林离岸风场如何用一个2年的计划来突破困境，翻转这个我们的逆境。首先呢，我们先提到说，专案在2022年底的时候，我们的状况是怎么样？在当时其实我们的制造是相当顺利的，在2022的那个当下呢，我们大部分的风机、电缆还有我的 foundation 都已经是制造完毕，甚至多数都已经是运送到台湾的状态。那各位可以看到，我们这边右上角的部分是我们的风机叶片，那右下角的部分是我们的机舱，然后左边这个是我们在台中港的5B 跟4C 码头已经陈列好我们所有的风机叶片、机舱还有塔架的部分。那这个部分呢是基础的部分，包含我们foundation的制造在德国以及在台湾，那转阶段制造在比利时以及在台湾，制造都非常顺利。那在运输的部分也很多都已经运到台湾。右下角这个是安平港的画面。那另外是海底电缆的部分，也已经在2022多数都已经运送到台湾。这个是台中港的画面。好，那我们遇到了什么问题呢？在2022的时至2022的时候，这个当下我们的施工其实是有delay 的状况。那其中包含了 COVID 的 delay， 以及一些施工上的困境，造成我们整体时程上的延迟。那更可怕的是，当时我们的 monopile 的 T&I contractor 他放弃了这个专案，所以我们在2022年底的当下，我们是一个专案 delay， 而且又没有 T&I contractor 的状况。那各位业界人士应该都清楚，你临时要找一个 T&I contractor，或者是临时要寻找一个施工船，那一是天价，那二是你只能什么东西就自己来。那我们选择了一个比较困难的道路，从2022开始，我们身为开发商，那我们没有 T&I 厂商，我们制造已经结束了，那我们 T&I 这个角色我们就自己做。好，我们自己成立了一个非常多人的 monopile 团队，然后把我们没有 T&I contract 这件事情全部自己扛了下来。好，那从这个时候开始呢，我们拟定了一个很明确而且积极，但是又负责任的2年计划。那我们决定在2023、2024的2年，把我们剩下的工作全数的完成。那这个计划包含了我们检点说2023年的当下我们拥有哪些资源，我们拥有一些当下可以用的船，那以及原本还有合约的这些船，那我们会把这些资源优先使用在比较关键的地方，例如说我们输出海缆需要的 foundation， 以及输出海缆的施工以及我们在海上在现有资源的船只可以先执行的基础以及风机。好，那并且我们在2023年同时执行专案的同时呢，我们也成立了2024年的团队。那在2023年的时候，这个2024的团队就专门开始准备2024所有的船舶，2024所有的工程计划，以及2024所需要的各项 logistic 的需求。好，那在这个2年计划的内容，我们在后面会再提到。那实际上带来的结果是什么呢？我们可以看到这个3个圈圈非常明显，在海上的3个大的package 里面，包含 foundation、包含 cable、包含风机。最深蓝色的部分是2022年以及2022年以前我们达成的进度。那蓝色的部分是2023年，浅蓝的部分是2024年。我们在2023及2024 2年完成了5%的 foundation， 完成了大概是超过7%的 cable， 以及7%以上的风机。那特别是在2024年，我们都完成了半数以上的海上的各项抗风能。那这个我们是怎么做到的呢？首先第一个，在我们设定了完成了2年计划之后呢，我们也非常感谢我们财务部分，我们在2023年8月达到了一个财务重整的 一个结果。那这个过程其实是非常辛苦且冗长的，因为在2022年底的时候呢，我们遭遇到了资金有短缺的情况下，短缺的情况就是投资人和银行这边已经认为我们已经有一个资金不足的情况，那他们有一个资金冻结的一个决定。那在当下呢，我们只能用自己本身母公司的出资以及4个股东的出资持续出资，然后我们在同时面临施工的压力以及财务的压力的情况下继续这个专案。那同时我们在争取投资人以及银行以及政府的共同支持，然后我们也很感谢在这段期间内政府给我们很多给了我们很多就是信心上的肯定让我们的投资人跟银行能够持续出资。那这也是因为我们在母公司 GIP 以及我们各的投资人决定自行先增加出资的情况下，才让投资银行成功的去增资云能风场，那达到了一个财务重整的效果。那这也是来自于我们因为2年的计划是可以让投资人以及政府来相信，才有我们财务重整，并且继续进行下去这个专案的一个结果。好，下一个很重要的部分呢，其实是我们在团队合作，还有就是 lesson learn， 就是一个经验学习的一个过程。那首先呢，从2019 financial close 至今，整个云林风场一直都是Skybone 以及我们的 partner， 这边 partner 我们有列出来，包含 Total Energy， 还有 EGCO， 还有 Sojitz， 这一些这个专案一直都是我们所有投资人里面最重要的一个专案。我们把所有的人力、心力，还有我们的最好的人力资源都放在这个专案里面。那前面刚刚有提到第二部分，政府的支持是我们一个专案可以持续进行下去的一个非常重要的点。这里面包含了就是对我们地方沟通的一个协助，那以及在我们财务不好的时候，状况不好的时候，仍然持续的相信云能可以最后可以在2024年做到这件事情。那另外有一个很重要的点是呢，就是在2022之前，我们的施工的工法跟2023年、2024有一个很大的一个改变。我们在2023、2024里面，我们全面性的检讨了过去的时程、过去的施工工法。那我们投资人不只是投入资金，并且也将人才投入到专案里的情况下呢，我们重新制定了整个打桩的标准作业流程，好，包含我们很多地质的专门的工程师以及船舶还有TNI 的专业的人才，我们一起来寻找一个最好的解决方案。毕竟 MP 在台湾是以前从来没有发生过的，那这个也是在台湾唯一一个使用 Monopile Foundation 的专案。那我们为此学到很多，那我们也建立了在2023、2024非常成功的 SOP， 去提升了我们MP 施工的一个效率，那同时也带动了我们海缆跟风机包的工作的效率。好，那这边有一点特别想要跟各位分享的是，在 MP 安装的一个挑战里面很重要的一个点，是因为我们有部分 delay 的关系，所以我们80座 MP 在制造完成之后，一直储放在2024、2023的时候开始储放在不一样的码头，包含我们现在看到的台中港、安平港，以及麦寮港。那我们在2024的时候呢，也很感谢投资人支持，我们在所有的 package 包含 MP，包含海缆、包含风机都有2组的主安装船。那 MP 身为我们的第一棒选手，我们面临的最大的挑战是我们 MP 储放的位置是在3个不同的码头。那我们有2组的 MP 安装船，那我们希望所有的 MP 安装船在施工完成之后呢，它的运输 barge 就帮它把下一个 MP 运送过来，那可以节省最多的时间，然后把握最小的天气窗去持续我们所有 MP 的安装这个动作。所以我们制定了一个非常积极、非常难以做到的计划哈，但是我们投入了非常大的能力，我们投入了非常大的心力，去确保在计划端跟执行端都是非常精准的，一点也不能 miss 的情况下，所以我们成功的达成在2024年用2艘的 MP 安装船去做到了达成45座MP 的一个记录。好的，那另外一个非常重要的点是，我们在专案管理部分的一个提升，我们希望提升专案对各个工作包的一个控制的状况，去减少所有的风险。这里面包含了时程，包含了risk， 包含风险，包含界面以及 stakeholder management。那我们所有的团队呢，都当然这个东西并不是2023之后才有，其实一直都存在。那只是我们身为一个赶工中的专案，我们必须不能有任何一点的疏失。我们的每天的时程的早会，然后我们每天对于风险的一个再检讨，对界面的不断沟通，那以及我们在地方的沟通，我们在政府的沟通方面，都做了比之前更大的心力，也投入了更多的人力。那以致在2023、2024的时候，我们所有的执行阶段几乎都按照我们计划的时程来执行，我们避免了可能发生的风险，我们避免一些界面上的不清楚，以及一个资讯上的不透明。所以我们在专案管理部分，在这2年也做了很大的一个提升。好，那这个部分呢是分享我们所有工作包在最后一个构件上了我们工作船的一个画面，右上角是我们最后一支的 monopile 云67，那这左上角不好意思，右上角是我们最后一支 cable 第83个 cable 上了我们的海岸船，那左下角呢是第80支风机上了我们的安装船，那右下角是第80支转阶段上了安装船 jumbo juggling。好，那最后一页这边我想要留给所有在 Skyborne 台湾以在云林风场工作的同仁们，我们所有的同仁不论资深或者资浅，不论你是直接参与或者是间接的辅助，我们都一起度过了这个最困难的几年，那我们都从最低谷的地方站起，并且去达到了我们想要达到的目标。所以我们现在可以抬头挺胸的说，云南风场这么困难的专案被我们完成了。那我们为了台湾的近邻也做了一份最大的心力。好，以上就是今天的简报，谢谢大家。
非常感谢王副总监带来的精彩分享，谢谢您。Next, we would like to invite Mr. Garo Shuska, Head of the Global Business Development of Siemens歌美颯 Offshore, to share with us the strategic view on offshore wind in Taiwan and APEC. Welcome. Please, the floor is yours.
Thanks for having me. Can you hear me? All right.
Yes, we can hear you.
Perfect.
Can you share your slides?
Yes, let me share my presentation. Thanks for having me. Of course, always nicer to see in person, but it's still nice. And thanks for still hosting it in a virtual way. I think the good part about the typhoon is it creates a lot of wind, which is good for the energy production. So I think for a lot of customers, it might be a good day as well. So hello from my side. Before I start, a few words to myself. Who am I actually? So I'm Gero Schuschke. I'm heading the offshore business development team in Siemens歌美颯. My development in the industry is now for 8 years in offshore. I started mostly on working for Taiwan specific topics, so and specifically the Taiwan localization, and then have grown in a role of more looking into APEC markets and also now into more global markets. Before that, I had a long history there, actually our mother company Siemens, as a consultant there. Today I wanted to share with you 3 aspects. So first of all, some of you know potentially Siemens歌美颯, and first a bit of a background who we are, what the company is about, and how we see APEC right now, where we're standing. Afterwards, I want to be a bit more specific regarding what we did in Taiwan, so how we approach supply chain development and our footprint in Taiwan. And then at the end, broaden a bit our view on looking at APEC in general, because we have also other growing markets in APEC, and this becomes more and more relevant to us as an industry. Starting with our company, Siemens Gamesa, we are a turbine manufacturer. So, for example, this is David Jason mentioned the turbine from Lynn. Of course, we are a turbine manufacturer, so we provide the turbines. We are active in onshore and offshore, and then, of course, service for the related fleet. Here in Taiwan, you will see us mostly offshore related. So in the offshore part, we have installed more than 2 gigawatts already, and we will start installing up to another 2 gigawatts from beginning of next year. But we are also active in Korea and Japan, so we have done pioneer projects, or have done one pioneer project in Japan, Shikari project, and we will do one we're constructing right now, one in Korea, Jeonnam project. Starting a bit with a global view. So if you look at the offshore market globally, you saw it in the previous presentations, it's a very growing market, and we as a leading turbine manufacturer, of course, see this growth as well in our order backlog. To give you a sense of where are we actually having projects globally, you see it, we are active basically in 3 continents. Europe is still by far the biggest market, and also the most growing market from absolute terms. Here the big countries are Germany, UK, but also now Poland, and other markets are coming more and more up. Then, of course, another very interesting market, a very dynamic market is US. The US market has had some setbacks, but also progressing in other directions. We are right now have several projects here, together with customers like Ørsted or Dominion. For example, one project, the Coastal Virginia project, which is 2.6 gigawatt, the project itself, which is of course a very gigantic project. And then in APAC, you see on the top right, this is kind of the order backlog. Order backlog is always confirmed order. We did not include any preferred supplier agreements or other areas here. So it's like booked orders. Yeah, in Taiwan, we are executing right now, we will execute the Greater Changhua 2204 project and the Hailong project from next year onwards with turbine installation, and the Yulin project is in the last run, I would say, to finish it. Our footprint in Taiwan specific, so Taiwan was clearly the front runner for APAC, and by being the first country in APAC to doing offshore wind, we also decided strategically that Taiwan will be also our hub for the region. So we have established now a footprint which is basically spread all across the island. So in the northern part in Taipei and Taiwan, we have more our regional office for functions like sales, engineering, PM. And then by now we have actually more employees in Taichung. In Taichung, we operate a cell factory. We operate a big hub for construction and pre-assembly works. And then we have also service technicians, of course, spread across where the wind farms are. So, for example, Budai is one of our service hubs. In total, we are more than 500 people already in Taiwan. So we have 530 employees right now. We are in the middle of a ramp-up period because we are ramping up our factory in Taichung. So this figure is expected to grow and to double in the next years to come. So for us, Taiwan is important and is kind of a home market for the region. But at the bottom left, you see also we are starting now to see offshore project coming in other markets. So Ishikari project we installed last year in Japan, very successful, very good project. And the Jeonnam project is right now in installation. We always start with like a rather smaller size project first to learn the market conditions. And this is why Jeonnam and Ishikari are also smaller size projects. And then from there, we basically grow into bigger projects. How's our turbine strategy or turbine deployment in APAC? We use a direct drive turbine. It's a direct drive turbine, so a direct generator, permanent magnet generator, and we're utilizing this now in 6th generation. So in in APAC, we actually deployed quite some different models. So in Taiwan, you will see a lot of 8 megawatt turbines, same turbine which we also installed in Shikari. This one is, for example, in the Yunlin project, the 8 megawatt turbine, or also in other projects like the Greater Changhua 0102. Then we deployed the 11 megawatt turbine at the Jeonnam project, and now for our project installation from next year onwards, a Hailong project, the Greater Changhua 2204 projects. Here we will install the 40 megawatt turbine. The 40 megawatt turbine has two different settings. The difference is basically the rotor size. For one turbine, we use a 108 meter blade length, for the other 150 meter blade. Also, for us, we expect that the turbine, the 14236, that this will be a turbine for a longer deployment in the APAC region. So also for future Taiwan, for example, round 3, but also for projects in Korea and Japan. There are also auctions ongoing, and this turbine type is kind of the turbine which we expect to be much broader deployed in the region. To give you some impressions of the projects we are doing or we did, just some nice pictures here. I think we had a lot of very nice pictures on Jason's presentation before. So on top left is the Yunlin, the Yunlin project. It's right now in the ending phase of installation for this year. Of course, for various players, a challenging project, but now coming to a happy end, which is of course great. And at the top right, you see the Ishikari project. The Ishikari project in Japan, the market is special in terms of certification requirements. And so for us, it was a very good, very successful learning project, which we achieved and managed to install last year. At the bottom left, you see the offloading of main components to Mokpo, which is a pre-assembly harbor, which we are currently running in South Korea. From there, we are installing the Jeonnam project, which is actually being installed over winter time. So it's being installed in the months to come. This is doable in some markets, in other markets not doable. In Korea, it is over winter is doable. So the weather downtime in Korea in the winter time is much less severe than it would be in Taiwan, where, for example, winter installation is completely impossible. And in the bottom right, you see a picture of the last loadout of the Greater Changhua 0102 project. It was by far the largest project which we had. So it was in total close to 900 megawatts by Rosted. And this one was finished, I think, last year or the year before. So how do we see our strategy if we look at the APAC region? So we always started from saying we need to anchor ourselves somewhere in APAC, and we decided with having the market in Taiwan, we will anchor our organization in Taiwan. And with that, we also decided to localize our very first nacelle footprint outside of Europe in Taichung. So this is what we did as part of the very first Greater Changhua project, together with the Hailong project, which is a very important project, project. We decided to expand this factory significantly and integrating a lot of local suppliers into our supply chain here in Taiwan. So this is kind of this year's second step. Now what we are working on is working to mature the supply chain, and then we need to bring in a regional view, because in order to be successful, in order to ensure that we have projects every year and we have a running factory which produces every year, we need to have a regional setup and a regional collaboration between countries in order to achieve this view. Right now, we are very much focusing on the maturing step and the regionalization step for that. But let me give you a bit of background on the next slides for these. So I think 3 months back, we opened our nacelle factory. It's a factory which is located in Taichung. So here we we are planned to hire up to 300 people. So you see a nice picture of our young workforce who is already hired. We are growing there more and more. It's for us a very important step, as it is the very first nacelle factory outside of Europe, which means we are bringing over a lot of knowledge and learnings from Europe to Taiwan, and with that, of course, we are also enabling a local supply chain to deliver into this factory, and having a proximity to this factory to utilize this really for the bigger markets. From our view, we plan to utilize this factory not only for Taiwan. Factories of OEMs, they are always dimensioned for bigger than one country. So also our nacelle factory is dimensioned for the region. So from here, from Taichung, we will serve the bigger region, and we are serving other projects outside of Taiwan already, starting very, very soon. Just to give you a bit of a feeling, so in the production, what we're doing is we are producing the hub, which you can see basically in the middle of the bottom. In the middle of the bottom, we are producing the hub. We're producing the back end, which is basically an entire back part of the turbine, and we assemble all the back end, the hub, and the generator together to one turbine, test it, and then basically deploy it. It's a quite diverse setup. What is important for us is in our diverse setup right now, of course, we are starting with a more diverse team. It's important to do that because we have a lot, of course, the learnings more in our international workforce, but our company strategy is to basically shift more and more to local and to completely local workforce. So, for example, the hiring, it's purely or it's 100% focusing on Taichung, which we are doing right now, and this is kind of the knowledge ramp up we are ensuring over this way. Why is such a factory important for the bigger region, or also for Taiwan as a country? Is you need a lot of components to build in a cell. To give you a feeling of this one, it's indicated here on the slide. You need around 2,000 different components to build a hub, 6,500 to build a backend, and more than 600 for the final assembly. So in total, you are close to 10,000 different components which are needed in one nacelle. And of course, with these so many different components, this opens up many supply opportunities to be integrated directly into the factory in Taichung. So a few examples, for example, Plasma ATEC, FACT, they are producing the canopy and spinner, so the outer house of our hub and our backend. These are produced in Kaohsiung. These are enormous big pieces to transport, and by having this production in Kaohsiung, it is actually from a transport perspective very efficient. So this is one example, but there are plenty of these examples why such a factory is so important. But of course, this also means that in order to make this factory work for other regions, it needs to be cost competitive. And it means that also our supply base on landed cost base needs to be cost competitive in order to export from here successfully into other region. And we also, of course, want that our Taichung factory is a very competitive factory in order to provide good turbine offers and pricing to the region of Taiwan. Now shifting a little bit the view on the bigger APEC picture. So if you roughly compare it, Taiwan was a clear front runner for offshore wind in APEC, and you see that in the red color here. The biggest market outside of mainland China, of course, was in Taiwan. But this picture is expected and forecasted to shift from 2028, 29 onwards. So what we will see is that markets like Japan and South Korea, they will gain much more significance with the years to come in 28, 29, 30, 31, and so on. So It means it is becoming more, APEC becomes more a market of 3 countries with kind of comparable market sizes who are growing the region. And for us, it's actually, as a turbine manufacturer, it's good to have this development, because the most important element for us as a turbine developer is that we have a stable installation every year. So we need basically to install projects every year in order to keep factories running, and in order to keep our knowledge in our installation and construction here in the region by having yearly installation and construction of turbines. So seeing 3 markets to come is extremely positive. And we actually feel that the importance of Japan and Korea will increase. And by that, of course, Taiwan also, we need to be careful that Taiwan basically is not pausing due to challenges which we are currently having in the industry. I think how I would name the countries, I think Taiwan is a front runner. Korea, we see as a clear, has the potential to be the clear floating leader in the region, and Japan has the potential to be long-term the biggest individual market of all in APEC. So having a comparison of APEC to other regions, so it is important to also acknowledge that an offshore globally is a very growing industry, and the growth is driven from many projects in Europe and also a big emerging market in the US. So to give you an idea, on the left side, we expect that to have more than 100 gigawatts being installed by 2030 in Europe, and also up to 26 gigawatts in the US, where basically nothing is installed yet. Why is this so important for APEC? Because it's important for APEC because it means there is also a competition for attention between markets. So I think we in APEC need to be sensitive and careful to not falling behind other markets by pausing or being too late for project deployments. This is important because the risk is, of course, once you have competition, that scarce resources like vessels, for example, and that they might focus more on the bigger markets first, and also in other markets, there's good credibility in terms of implementation time and given of projects, which once in a while we struggle a bit here in the APEC region, or for example in Taiwan specific, around 3.1 is a good example for that. But as an opportunity, of course, what arises out of this one is if it's there is a lot of potential of Taiwan, Japan, and Korea to work closer together in a regional sense. And if this is managed, it creates a lot of potential and a lot of benefits for the industry. So, for example, if we manage to establish and strengthen a more regional supply chain, this would actually would help us to use basically use and connect basically countries and country suppliers with different talents, with different strengths, and making the entire regional production more competitive. Also, what is a big opportunity is if we have 3 countries, of which each year there will be an installation project, and we make critical equipment available across borders, this is a big upside for us. So, for example, if we would find a way to use vessels across borders in Japan or Korea or Taiwan, and having like regional hubs, for example, on the service side, which is deploying across the 3 markets, this is a big synergy which is given between the markets. And of course, on the talent side, it's also important that we now had a big learning from bringing a lot of knowledge more from Europe to Taiwan. Now we have like a big fleet in Taiwan. And now for us, it's very important that we bring this learning now from Taiwan also to Japan and Korea to basically spread the similar offshore learnings and to other markets. And this is, for me, also coming to my last slide here is we are very strong embedded in Taiwan, in the Taiwanese market, and we really want to to have Taiwan continuously leading offshore in the APEC region. But for doing that, there are several things which we need to acknowledge, because currently the industry is really, really struggling in Taiwan, and we need to find a way that this is being overcome. So the most important priorities and the most important factors which we see is that now we see projects being successful in terms of financial close. There's a lot of challenges in around 3.1 projects to materialize, and we see delays, we see project getting cancelled, and we need a way that these projects coming to a financial close to ensure that the market is continuing to deliver, because this is what is so important, to keep local knowledge, to keep factories, and to keep everything running in Taiwan. Second is execution trust. So I think we had now a very good year in 2024 of projects being actually delivered and progressing on time, and delivered, progressing very good and delivered on time. So I think this execution trust to deliver projects in a foreseeable manner will help us more and more to gain, again, trust on the finance side. I think 24 was a very good year, and I think 25 for us, we are looking very much forward to this one, to continue this path with the two upcoming projects. For number 3, of course, right now there's a lot of talks about changing of rules. So we support government in all ways how they want to shape the industry. What for us is mostly important is that this is being conducted in a sensible way. So a sensible way means that market players have transparency and trust actually in timelines of future auction, of future rules, and that we can basically adapt to changing path on the run. So what is difficult to do is there's like a too big change out of the blue. So I think this is a sensible way, managing to put the industry forward and in a sensible way of adapting legislation and regulative environment where needed. This is what we support a lot. And the last one is, it's all about for us to deliver also competitiveness. So I think for us as an industry in general, it's important to lower the gap between fossil fuels and offshore wind. Here in Taiwan, there are a lot of hidden cost drivers. For example, on regulative or policy-driven factors, local content is one of them, but there are also elements like vessel requirements, operating costs in harbors, which is basically hindering to reduce the cost of offshore wind. And of course, on the other side, there are also kind of subsidies or hidden subsidies on the fossil side, which is making the gap bigger. And for us, it's important that this gap between fossil and renewable, offshore specific, getting closer and closer, more narrowed, and that we as an industry tackle this over time, but also that we are supported from the policy and the other players in the market to grow in that direction. That's for me. So thank you for having me. And next time in person, hopefully tomorrow the fair is opening. So maybe a few of us see each other tomorrow as well.
Thank you, Mr. Shuska, for your informative presentation. Thank you.
Thank you.
Next up, please. Thank you. Next up, please join me in welcoming Mr. Ben Darrington, the Chief Operating Officer of Dongfang Offshore. Today, he will be sharing insights on successful cases studies in offshore wind transportation. Let's give a warm welcome to Mr. Ben Darrington. Please take it away.
Hi, thank you very much, and thank you for the opportunity to allow me to speak at this seminar. So today I'm just going to give an introduction at Dongfang Offshore, a little bit about our company. We're going to talk about some of the challenges that we see when working in Taiwan, and then we're going to go through some case studies of some recent DFO projects, and also how we believe that we can help continue to improve the competitiveness of our offshore wind here in Taiwan. So Dongfang Offshore was incorporated in 2019 as an affiliated company of Honghua Construction. Today they are our largest shareholder, but we are an independent company that operates exclusively in both the offshore energy space and the telecommunications space within Asia Pacific. We own and operate the largest pure play renewables fleet in the Asia Pacific region, with 16 vessels either in the water or under construction. We have a growing project execution and track record, being able to execute more and more complicated projects. We've managed to develop an in-house international standard ship management organization to deliver high-quality offshore operations. We own and operate the most modern, best-in-class equipment that we can find. So we are not compromising on quality. We maintain a very long and strong stakeholder relationships, and we employ over 300 people in the Taiwanese market today. We have a very clear strategy and vision. The first is that we buy or build best-in-class vessels and best-in-class equipment from the top manufacturers and suppliers in the world. Most of our vessels are actually built in Europe, and we continue to build vessels with international equipment and to an international standard in some of the best shipyards in the world. Secondly, we operate the organization with the highest quality talent we can find. And we take people from all over the world to help build an organization that is uniquely Taiwanese, but also international. And we have over 50 nationalities of both onshore and offshore. We also invest sustainability with long-term view. So we believe in prioritizing long-term value and long-term sustainability of the supply chain and our business over short-term or opportunistic profits, which is why we have invested again in best-in-class equipment. And our goal and our promise to our customers is that we will work to deliver local services that are equivalent or better than those that you can buy from the European market here in Taiwan. We work with two different kinds of customers. The first kind of customer we work with is developers, and we have strong working relationships with almost if not every developer here in Taiwan today. And then we also work very closely with manufacturers and contractors within the offshore wind industry, so the likes of Siemens Investors, as well as many different contractors who are actually constructing the projects. Our business works in three different verticals. The first vertical we have is cable transport and installation. So we install cables utilizing our cable laying vessel, the Orient Adventurer, that's just finishing her first year of cable installation works here in Taiwan. We support that with our Orient Constructor, which is our ISV TSV installation and trenching support vessel. And we also own a fleet or have access through our network to a large fleet of nearshore support equipment. Our cable transpooling base in Taichung Port, where we have made a long-term investment into developing a state-of-the-art facility there. And we're also able to deliver the turnkey scopes together with our partner CS7. Our second vertical is operations and maintenance. Today we have, I think, over 50% market share in long-term O&M for turbine works, with two new build service operations vessels that we have ordered from VARD in Vietnam, so a Norwegian shipyard in Vietnam, that will be deployed already onto long-term contracts with our customers when delivered, and we're looking to build more against certain contracts. We have 7 crew transfer vessels today. We also have an O&M cable storage facility in Taichung Port to store spare cables. We have the ability to conduct repair and reburial works of cables, and we can deliver other O&M scopes, and we're exploring that today. We see O&M is very, very important to our business, and we're very happy that a lot of our customers have continued to trust DFO to deliver high quality bird solutions here in Taiwan. And then our third vertical, and this is a new vertical for us, but our third vertical is acting as an EPCI or T&I contractor. So we're slowly growing that capability and carefully growing that capability to execute larger projects. Today, we are executing our first major EPCI project, an $80 million telecoms cable EPCI project, where we're laying over 500 kilometers of fiber optic cable amongst the islands in Taiwan. We also use this vertical to execute smaller offshore wind scopes for both main contractors and developers here in Taiwan. Our fleet totals 16 vessels, of which we have 2 construction support vessels. One is working as a cable laying vessel, and the other one is working in the trenching and installation support mode at the moment. We own 5 CTVs, and we operate 2 CTVs on behalf of other parties. We own a fleet of anchor handling tugs that work primarily as guard vessels in offshore wind farms. We have a survey vessel, the Orient Explorer, that is being utilized a lot for bathymetric surveys, a flat top barge, and then 2 new construction, actually cable repair service operating vessels that are being built for our customers here in Taiwan. So a little bit about our fleet. This is the Orient Adventurer. So this is the largest vessel in our fleet. It is our cable laying vessel. It's in what we call the version 1 configuration this year, and it currently works on the Yunlin project. EP3 vessel, 130 berths, 270-ton vertical lay system, 15-ton horizontal lay system, 2 work-class ROVs, a big subsea crane. I think she is the second largest Taiwanese-owned construction vessel after the Green Jade here in Taiwan, and it's the first Taiwanese power cable installation vessel within the Taiwanese market here. So we it's a lot of work to develop this product, but we're really happy that that this year she's had a successful season on the Yunlin project. Our smaller vessel in this category, the Orient Constructor, is currently working on the Hailong project. She's working in the ISV mode, so she supports many different campaigns, and it's actually one of our most successful case studies to date. Explain that a little bit later in the presentation. DB2 vessel, built-in rig-to-work system, a 250-ton crane, and capable of accommodating 102 people. We own a fleet of smaller tugs. These vessels are typically used to guard the offshore wind farms, and we offer package services for wind farm guarding service. Our survey vessel, the Orient Explorer. Our state-of-the-art CTVs. We have, unlike other owners within this market, we took the decision right at the beginning to invest only in brand new, purpose-built, state-of-the-art vessels, and with the goal of becoming the preferred supplier to both O&M and construction phases of offshore wind farms. We operate 6 of the Damen 2710 and 1 of the Damen 2610. These are the largest, most capable CTVs that are available for sale in the market today. We've also ordered 2 CSOVs. These 2 vessels are built for 2 different customers within Taiwan, one of which has been announced, Fengmia 1. They are chartered long-term to them, and they're capable of not only supporting the O&M phase of an offshore wind farm, but they also support cable repair and other scopes that are necessary to complete the total maintenance package on a wind farm. They have built an integrated warehouse, integrated work-to-work, 120 beds, and DP2, and they're really customized for the Taiwanese market. One of the reasons I believe that we were successful in securing both these contracts is because we took all the lessons that we have learned over the last couple of years working in Taiwan, and we've applied them into these vessels, which we expect will actually perform very well in Taiwan. We also work on third-party services in Taiwan. So this is another one of our vessels that we do in combination with various partners, rather than Helix. So we deliver a full scope trenching service. We've been doing that now for 2 years, where we're able to bury and rebury cables in both soft and hard soils. We offer that as a standalone service to a lot of our customers today. There are quite a lot of challenges working offshore in Taiwan, and I'd like to cover a few of them. The first challenge in Taiwan is that there are very extreme weather conditions. There are very, very strong surface currents. We have seen surface currents of up to 6.5 knots, which is unheard of in Europe, but very, very, very strong surface currents here. And that makes station keeping and maneuvering the vessels very challenging, both small and large vessels. The second challenge that we have seen in Taiwan is a very long and persistent swell that sweeps through all of the sides and induces motions in the vessels, even in calm conditions. And it's something that needs to be prepared for. And again, it's something that you don't see so much in Europe. And then the third big challenge is that the conditions change rapidly in Taiwan. Unlike Europe, where I think both the weather forecasting, but also the change of conditions is a little bit, the weather forecasting is better and the change of conditions is a little bit slower. In Taiwan, we see that the conditions change very, very, very fast, and sometimes in unpredictable ways. And the boats need to be built for that, and the operation needs to be set up to plan around this. The second major challenge that we see in Taiwan is very high interface heights combined with deep water sites. So what does that mean? Well, firstly, offshore wind farms are being installed in much deeper water than most projects in Europe. We have seen projects installed in up to 70 meters of water in Taiwan, which is again unheard of in Europe. And because of typhoon induced waves and other environmental conditions, the connection point, the interface point to the wind turbine generator relative to the sea surface is very, very, very high. What we understand, talking to people that work in Europe, is that these heights are up to 2 times higher in Taiwan than in Europe, and that means actually that a lot of this combined with the weather conditions for the strong surface currents actually mean that if developers, suppliers, and vessel owners use European assumptions, or if they bring European vessels to Taiwan, they actually struggle significantly with the conditions. And we've been developing solutions that attack these problems head on to ensure performance. But it's just something to bear in mind that these two things together actually cause a lot of problems for European vessels, and we've seen that with the European vessels that have come to Taiwan. And there are reasons why we have invested the way we have in the assets that we have today. The third big challenge that we see in Taiwan is very challenging geophysical and geotechnical conditions. So, and this applies primarily to jackups. The soils in Taiwan are very, very, very soft. So if you do jack up a wind turbine installation vessel in Taiwan, you see that the legs of the jackup penetrate deep into the mud and the sand that's offshore, and you need longer legs to be able to manage the conditions. It also makes it challenging for cable burial, because we see some variability in the soils, and it means that we have to change a tool or manage burial with different tools in order to successfully bury cables. The second big challenge with the geophysical conditions is the fact that there are large sand waves that move across wind farm sites. And that makes it really, really, really challenging to both bury cables, but also manage the burial tools across those sand waves. And we see that cables are regularly exposed because of this. Further, there are large intertidal areas in Thailand, so large shallow areas near the coast. And that makes it very challenging to pull export cables into the shore or repair them if they're damaged. Again, of course, as DFO, we have worked through many years of offshore wind in Taiwan, so we've understood these problems. But we deliver solutions to solve this. The first solution is we make sure that our vessels are fit for purpose. So we make sure that the vessels have sufficient power. We've seen a lot of underpowered vessels come to Taiwan that really struggle in the conditions here. The second solution that we developed is that we make sure that the vessels are long enough in order to combat the long swell and are set up to basically have low motion in those types of conditions here. The third solution that we developed is we have a lot of very interesting technical innovations handled at very, very high landing heights. Again, we have been observing very closely a lot of vessels working in Taiwan, including European vessels that were selected because of good performance in Europe. They struggle in Taiwan, but we have learned a lot from other people's performance and also our own performance. And we've developed really interesting and exciting technical innovations that we provide to our customers to manage accessing structures that are very high up above the sea surface. And then we also think very carefully about how we operate those vessels in Taiwan. When we apply all of these lessons learned, we're able to achieve much higher workability and accessibility, which translates into higher uptime for wind turbine. We see that European specification wind to work vessels here in Taiwan achieve accessibility of somewhere between 10 and 20% over the winter. In the winter, CTVs have almost zero workability, which is very different to Europe, where in Europe you have a little bit of workability in the winter. In Taiwan, basically zero. And then DFO vessels. When we're able to implement all of our technical innovations, and we have demonstrated this over the last couple of years with our vessels, we've achieved workability gains of over 50% to 70% more than European specification vessels and European vessels that come into Taiwan. And that's by applying a lot of the technical innovations that we have developed to ensure that we have the right assets in place. It is also noted that there is a lack of spot market vessels within this region that can conduct suitable work. And that's really important to raise also. Even within Asia, the Asia-Pacific built vessels are not really built for the Taiwanese market or the North Sea market, actually. So we find that those also struggle in the weather conditions here. This is our brand new CSOV. A couple of the interesting technical innovations that we have done that we can share with you is we have selected propulsion that allows us to keep very, very tight DP footprints to manage safety offshore, which a lot of our competitors actually don't do. It costs a lot more money to do this, but it greatly improves safety, reliability, and workability, and also allows us to add active roll reduction, which again increases safety, but also workability. We've developed a vessel with very, very nice hull lines that's designed to again reduce motions, especially in these long swell conditions. And then finally, we've implemented state-of-the-art equipment that is designed again to compensate and manage the accelerations and the motions when you're transferring in high sea states in very difficult conditions with high transfer heights. We see a couple of challenges of operating within Taiwan, even as a Taiwanese domestic owner, which makes it sometimes difficult when we are discussing our projects with and we're competing against European owners. The first one is that in Taiwan, we have a very high tax regime for vessel owners and contractors. Within Europe, it is common to have a very, very low or no tax regime. Typically for vessels, we have a tonnage tax regime in Europe. In Taiwan, we don't have a tonnage tax regime. So Taiwanese owners are already at a significant disadvantage, or Taiwanese contractors are already at a significant disadvantage because they're paying quite a lot of money in income tax relative to European contractors. The second big challenge that we in Taiwan have as a Taiwanese contractor is that there's actually a very large import cost for our assets into Taiwan, which foreign contractors are not exposed to in the same way. The second big challenge that we have working in Taiwan is that there is a serious shortage of qualified personnel. Taiwanese flagships require Taiwanese crew as part of the minimum manning, and these crew are in very limited supply. So we have been training a lot of our own crew in-house, but we also do need to double up significant numbers of crew. And the third thing that we struggle with versus European owners is actually that we don't have the same the same schemes that European owners do. We don't have access to, for example, the X-fin schemes that Norwegian owners have, at least not to the same extent, which has spurred significant domestic shipbuilding and ship owning in Europe. We lack domestic subsidy schemes, which exist in Europe, especially for specialized installation of innovative or specialized technologies. And so we find we can be quite uncompetitive against European suppliers because they're effectively subsidized by Europe. And then we also see that we have limited double taxation agreements as Taiwan with European EU, European-linked countries and countries outside of Europe too. And that also significantly drives our costs because for many things that we purchase from Europe or for many things that we contract in Europe, we are actually taxed twice. I'm now just going to go through a quick study of the Orient Constructor and a case study for our project. The Orient Constructor, which is our trenching and installation support vessel, has been chartered to Seaway 7 for actually this should say 2024 season, so my bad, but for the 2024 construction season. This vessel was initially envisaged by the developer and by Seaway 7 to support cable pulling. But we have worked very closely with the developer, with the contractor, and with other contractors to complete multiple scopes. So today, the Orient Constructor on the Hailong project has completed cable pull-ins, has completed cable test and termination works, scour protection installation, so installing rock bags around the foundations and the cable routes, and also commissioning the offshore substation. We do also complete some smaller scopes as a contractor around the wind farm relating to survey and buoy installation. And by delivering synergy across all these scopes, and by being able to provide the developer this flexibility, I think we've managed to actually deliver significant cost savings to our customers. This is an example of us working initially as walk to work, but then installing scalp friction. And this is the Orion constructor working offshore in the Hai Long project. You can see the green jade in the background, which is the largest Taiwanese construction vessel, and the Orion constructor, which I think is the largest subsea construction vessel in Taiwan, working together to deliver a project in 2024. Then my final slide here, the means to maintain competitiveness that we see within the Taiwanese market. The first thing that we would actually really like to see is that both developers and contractors look at vessels like infrastructure as opposed to something that they can rent like a car from the open market. Today we've seen companies like Siemens, Tianli, invest in factories, and a lot of European companies have invested in factories and hard investments in infrastructure. But we think that vessels should also be looked at like infrastructure. And I think it's important that both developers and contractors look at contracting vessels long term to deliver offshore wind ambitions in Taiwan. This will not only ensure that contractors get the most attractive price, but it will also trigger new investment and solve the vessel shortage. The second challenge that we see within Taiwan for the domestic supply chain to maintain competitiveness, and what we hope will happen in the future, is we'd like to see more domestic engagement in the supply chain, because we've seen that a lot of the procurement decisions are made out of Europe for projects in Taiwan, and we understand why. But at the same time, we think that the local supply chain has a lot to offer. But the best way to get everything the local supply chain has to offer is to drive local procurement with people on the ground in Taiwan. We hope that, of course, all stakeholders in the industry can continue to work to develop and to deliver knowledge transfer to the region from Europe to here. We continue to be very, very open as a local supplier, and I know a lot of our peers are, to continue to absorb the knowledge and experience from Europe to ensure that we can build a competitive domestic supply chain within Taiwan. But of course, that requires a commitment from our customers, a certain commitment from our customers, and a certain willingness to do this from our customers. Make that happen. And then we hope finally that the foreign developers and contractors that are here continue to build trust in a local supply chain. There is now a growing supply chain in Taiwan. We hope that others follow our lead in working to develop a European standard or better than Europe standard supply chain within Taiwan. And we hope that we can continue to build trust with all customers in Taiwan to continue to do this. And with that, that's the end of our presentation. So thank you very much.
Thank you, Mr. Darrington, for your insightful presentation. Thank you. Moving on, we will explore the challenges of mooring line configuration and supply chain challenges with Mr. Nathan Lowe, Regional Business Development Manager of Mooreast, and Mr. Louis Stevenson, Technical Sales Engineer of Mooreast. Please join me in welcoming them both. Please take it away.
Thank you for having us. So I'll do a quick run of introduction to Mooreast, introducing our company and corporate profile. Then I'll run through a quick overview of the floating offshore wind supply chain, in particularly focusing on the mooring systems. And my colleague Lewis will cover on the overview of fabrication and the overview of storage requirements when it comes to handling mooring systems. And we'll end off with some interesting keynotes to take away for today's session. So Mooreast is a Singapore headquartered, and we are listed in the Singapore Stock Exchange. We are currently the leading mooring solution specialist in Asia, and we are one of the top 3 ultra-high holding power anchor designers in the world. And existingly, we do our designs in-house, basically from analyzing the geotechnical soil conditions of the site, and to be able to provide detailed specifications and suggestions to our client in terms of selections of anchors. And we will deep dive into the engineering part of things, fabrication,
and also supporting the installation companies in terms of procedures for anchor installations. So this puts us basically being able to provide a total mooring solutions to our clients. So at the moment, we have our headquarters in Singapore, where we call it the Mooreast offshore base. This current facility is 320,000 square feet size. We have a 200-meter waterfront berth with a water depth of about 6.5 meter. And our total steel throughput for our current production line is about 1,000 tons per annum. And we are actually proud to announce that we also recently acquired an adjacent facility near to our current one, which is currently owned by Seatrium. It's called Seatrium Crescent Yard. This facility is in total about 1.1 million square feet, which includes its waterfront facilities as well. And we basically are gearing ourselves up to undertake large-scale fabrication of subsea foundations for the renewable sector. So our current new facility is about 989,000 square feet with an 865-meter waterfront berth. And basically, this current facility would enable us to also act as a staging hub or logistic hub for our clients and cross around Europe and Asia projects. So with a total of about 2 facilities, we have in total about 1.4 million square feet of land area, and we are able to cope with about 2 gigawatt of mooring systems per annum. And this would mark us as the largest subsea foundation manufacturer globally. And we are proud to announce that basically we started off our renewable journey since 2013 for the Fukushima Forward project in Japan. And basically that is the 10 years of experience of catering mooring systems to the renewable industry alone. And I'd like to also highlight in 2016, where we supported FloatGen in France for 2 megawatt dampening pool foundation mooring systems. And very recently in 2024, we were awarded the ILMED France project for a 30 megawatt commercial scale project and supplying the anchor systems as well. So all in all, in our renewable journey, we have done 29 various projects in our renewable portfolio. Out of 29, 21 projects were floating wind farm related. 4 of them were floating solar projects related. And we have supported in total about 7 different major countries in terms of our mooring system, and up to 86.3 megawatt with the various sizes of about 2 in terms of demonstration project, up to 15 megawatts for commercial scale projects. So in total, for our renewable portfolio, we have supported about 1,700 tons of steel fabrications and about 83 units of anchors in total. Throughout our history, we have majorly provided services for the oil and gas sector. And in terms of deployments of project, we have deployed in total of 26 different countries in total. And the blue dot represents our current office location, and also together with our partners. And we are proud to also announce that this year we have established our subsidiary in Taiwan for Mooreast Taiwan Limited. So in terms of the mooring foundations, we have capabilities to design and engineer various types of anchor solutions, which the common ones used in the floating wind farm is the driven piles, drag anchor, and of course the suction piles as well. And torpedo piles are more often seen in the deep water region for the oil and gas sector. So we have more than 30 years of experience delivering mooring system solutions to our customers. As I mentioned previously, we start off with the geotechnical and geophysical solutions, being able to integrate the soil data and provide the anchoring device selection. And we will deep dive into the design and engineering solution, which includes the mooring system design as well. And also provide performing FEA analysis for the anchor system and hydrodynamic analysis included as well. But another part of section is, of course, the fabrication of the mooring systems. We are capable of fabricating the high holding power anchors, inclusive of the chain stoppers, any tensioning jack devices, and also surface buoys. And through our procurement strategies, we supply also the mooring lines, which includes the chains and ropes, and also connectors. So building out from our core expertise in total mooring solutions, we also spun off with a few other capabilities in terms of the adjacencies. This gives us a full operational understanding of handling the mooring systems for our client, which includes the rigging lifting, which includes the rigging lifting supplies, and also mobilization, activation of vessels for yacht services. So this gives us a good experience in terms of the operational segment of the mooring system supply, including from the marshalling point, handling the logistics, all the way to the installation stage. Now, in Taiwan, our unique cooperation with our local partner here, Lenta, and also Ezion Marine, gives us the advantage to basically support them through our experience to provide an EPCI model kind of provision of contract. But for us, for Mooreast, basically we will be focusing on the EPC of mooring system, while Lenta and Ezion will be focusing on the approach in terms of transportation, logistics, and the installation offshore activities. So the next part, I'm going to give you a little bit of overview of the supply chain, focusing on the mooring systems itself. And we extracted this data from GWEC showing the potential of floating wind offshore in Taiwan. I think a few of the colleagues have also presented before this with regard to this data, but to highlight on the floating wind potential in Taiwan of about 86%, gives us a good understanding about how should we strategize in terms of floating wind farm procurement strategies or supply chain strategies. To give everyone a feel in terms of what does the commercial project looks like, we performed a case study based on a 500 megawatt project. The total project capacity includes 34 units of turbine in total, which is average about 15 megawatt per turbine. And we are looking at 6 mooring lines per floater. And this would be in total about 204 mooring lines. Now, out of these 204 mooring lines, the total steel throughput in terms of anchor chains and chain stopper, we are looking at about 86,000 tons of steel throughput altogether. And this is equivalent to about 12 Apple towers in total. Now, in terms of the mooring line configurations, I'd like to give you an overview from the top section, from the chain stopper all the way down. So first, we start off with the chain stopper arrangements, going down to the top chain of a 50-meter chain, and the mid-section of the polyester rope, which is about 160-meter length, and going down to the bottom chain, which is about 600-meter length. And in average, we are looking at a 31-ton anchor, drag embeddable anchor configuration. So each of these floaters would have 6 mooring lines, and multiplying it for a 510 megawatt project, we are looking at a total of 6,300 tons in terms of anchor fabrication. We're looking at a total of 132 kilometers of mooring chains with an average size of 165 mm diameter. We're looking at about 32 kilometers for the mooring ropes and about 7,000 tons for the chain stoppers. So this is basically the quantum of what are we expecting in terms of the mooring system configurations for a commercial scale project. And in terms of timeline, assuming that if, for example, the contract award date is second half of 2025, you can see here that the last final delivery of anchors would be in the second half of 2028. And this includes the engineering period as well. So all in all, for mooring system for a commercial scale project, we are looking at approximately of 3 years from the engineering detail design all the way to the final delivery of anchors. The next part here, we extracted out the data from GWEC as well, and we did a simulation of the typical 15 megawatt turbines using a 6-line mooring system. And based on the next 5 years of mooring line production, we are expecting that there will be about 1,482 units of mooring lines in total in the next 5 years. And using the same average of 31-ton anchors, we are expecting that for just the anchors, we are looking at 46,000 tons of steel throughput altogether. Whereas for the chains, based on an average of 160 mm diameter chain, we are looking at a total of 2.35 million tons of steel requirements. So this would give us a good overview in terms of just the steel requirements alone for the mooring system itself. Now, using the same data, we also compute based on the supply chain capacity globally, where the conservative supply chain is estimated at an 80% of the global capacity, and optimistic supply chain at 100%. And based on this supply chain capacity versus the demand, we can see that the demand would exceed the conservative supply chain by 2029, and the demand would exceed the optimistic supply chain by 2030. Now, of course, considering the optimistic supply chain may be not realistic, because we also have to consider the oil and gas projects that are ongoing as well. So it's very important that all of us would consider, especially on the developers, to work out a supply chain balance strategy. And the 4 key areas is basically on the fabrication, logistic, storage, and installation. But today, my colleague will be deep diving in the fabrication and storage segment. As you may have followed us in our previous presentation before, we have given a bit of an overview of all these 4 quadrants. So now I'm going to hand over to my colleague Louis to give you a deep dive on the fabrication and storage. Thank you very much.
Thank you very much, Nathan. Good afternoon, everyone. So I will be giving an overview of the fabrication, the considerations and strengths of a large fabrication facility. So as Nathan pointed out about the supply chain constriction, these are a lot of things that should be considered when looking at a new supplier. So if we were to start off with the top left, location is a very good thing that needs to be looked at. And it's quite an obvious one where if you are closer to the wind farm, or if you're within the close proximity, it's going to be a great benefit. But this is not always the case, as this is a global industry. But what's something you should consider is if it's close to a shipping lane, as this is, in most cases, you may be looking quite far for specific components, but there might also be the case of local content, but this is also quite difficult. And the next thing to consider is if the supplier has access to a quayside, or if it's landlocked. As we noticed that we're at 15 megawatt turbines at the minute, but things are continuing to get larger, which means that the transportation of components via road is increasingly more difficult. And especially when you start to consider the likes of steel chain and larger ankles, it only makes sense to have a quayside if possible, or at least one very close by. Moving on to the right, material security. This is something that Mooreast in particular really looks to, as we have raw material on site. It's something that we purchase early on by looking ahead in advance. And this is what allows us to start work almost immediately. Because if not, with the global constriction that Nathan has highlighted in the supply chain, if you're waiting too long, you won't be the only person to put down an order for the raw material, which is generally steel in an anchor's case. But this is something where if you put further back in the queue, then you're waiting longer. And then by the time it arrives, if there is any defects, for example, then you run the risk of a much further setback where you need to send it back. And by being able to have that steel on site to start immediately, you get better control and visibility of the whole process. Moving down to the bottom left one, where you can see the nice video there. Equipment control is important. That ability to, as I said about starting immediately, being able to cut and roll the steel on site is very important, because it gives you that control over the price, but also the timing of the process. Because there's a lot of scenarios where if you're possibly shading it, if you're shading the crane, for example, then you may need to wait in the queue, or it might follow with very high day rates. And as I said about floating offshore wind farms getting much bigger, the sizes of crane, for example, will become much more costly. And then lastly, the testing and qualification on site is another great benefit as well. And last but not least is the yard space. And this is something that I will touch on later regarding the size of batches. But of course, the larger the site you have, the more flexibility you have, which is a benefit. And if you're able to produce larger batches, it takes away the strain on the vessel in terms of potential number of trips or the idle time, where you can be the one that's flexible to the vessel coming in and leaving, or to the size of vessel as well. Something that's also important is the complete mooring system package, which Mooreast is particularly looking into, where if we are able to also house the likes of the rope or the mooring chain, then we can help that offer better cohesion between the T&I, the transport and installation company, as we can offer an additional location which takes the pressure off the marshalling port, for example. And then we can also work in tandem with that marshalling port. So moving on, so that was the early considerations. But what type of benefits for a large-scale manufacturing site might that have? Well, the number one at the top of the list, which I think everyone is always aware of, will be the reduction in cost. And this is from removing inter-facility transportation costs, reducing subcontracting profit margins, and also the ownership of fabrication and movement of equipment. And this is something that's quite important. So I touched on that and how that can stem from the material security, equipment control, and location. But what's sometimes overlooked, especially in cost models from early on in the project, is they will look at individual component costs, but a lot of costs in terms of movement or the additional subcontracting costs, where it's the cutting of the steel if it's done at one site and then it's transported somewhere else. These can be quite easily overlooked. And for oil and gas, for example, where you're looking at, say, 10 to 15 anchors, it's not too much. But when you start to really look at a commercial scale wind farm, where you're looking at 200 to 400 anchors, these costs really start to build up incrementally. Moving down to is reduction in transportation, which can result in lower emissions, less risk of delay due to transportation, and you can avoid the vessel competition. And I think we already know the cost of vessels today is quite high, but they're only likely to increase at the minute with the competition, not just for floating offshore wind, but the oil and gas market will still be there and they will still be using vessels. Lowering emissions is also a great benefit, especially if we try to get to net zero. It might not be first on the list. However, it is something that is worth considering, as in many countries around the world, upcoming leasing rounds have started to take into account environmental considerations, such as life cycle analysis and carbon accounting. And last but not least, improved logistics. You can begin fabricating immediately. As I said about having that material security, you can start right away. You can help avoid those queues and delays as other wind farms are starting to come online and have the same timeline. There's also on-site QA/QC, allowing seamless control and robust inventory control. And lastly, visibility of the whole fabrication process. This is particularly important, especially from a developer or the lead for the project, as if you can, the more that you can press into one area, then it reduces the logistical and almost project management burden of them having to visit multiple sites. If you're split into fabricating in multiple areas, they can come to the one site, see everything that's going on, have a good understanding of where the project is. So that was a good overview of fabrication, but moving on to the storage now, which I can promise includes more pictures now. To give you a quick comparison of the different anchor sizes that are generally used in floating offshore wind, the most popular is the drag embedment anchor, the driven pile, and the suction pile. And this is a good example in terms of the different sizes. On the left, you can see a good comparison, which shows 3 anchors that have all been taken to the same design load. But one thing that is worth highlighting is that the weight and length is significantly reduced for the drag embedment anchor. And one of the reasons for that is the safety factor required for the driven pile and suction pile is around 1.2 and 1.3, which causes them to have that increased required ultimate voltage capacity. But the main point I'm trying to make for this presentation is that the size that comes with them, as you can see from the image on the right. So when you are looking to store these at the quayside, for example, it will become significantly more challenging when you look at that increased weight and increased length. But I have some more pictures which will help better illustrate that. So on the left, we have the drag embedment anchor, which can also be separated into 2 components, which is top left is the shank and the bottom left is the fluke. And the flukes can also be stacked to help reduce that. And you can see there's, I think, about 8 on that truck at the minute, which is again helps reduce that operational and transportation burden that you might have with different types of anchors. In the middle, you have driven piles, which are generally stored horizontally, which can be quite challenging as it almost becomes similar to a monopile, which I know that I've seen a lot of them have been stored in multiple Taipei ports as Fixed-Land is currently ongoing. And then lastly, on the right-hand side, you have the suction piles, which can be stored vertically and horizontally, which again help reduce that compared to piles, but you also have some other challenges with movement due to the height restrictions. But it's not just about anchors, as the ports will also be housing the mooring system equipment. And on the left, you can see the synthetic rope, which can be stored in reels, which is a good benefit. It's had a much smaller footprint compared to chain, which is definitely the most demanding, which is stored in which is stored in bundles or lines. But one consideration for the polyester rope or synthetic rope is that it should be stored indoors if it's for long periods of time. And in terms of what does that look like on a live site, so this is the facility which Nathan touched on earlier, but you can see just on the left-hand side, circled in red, some mooring line chain, and then just above that you can see the anchors split into two already, with the flukes also stacked on top of each other. So there's quite a number of things going on in this presentation, but to dumb it down slightly, just so that we take away the main points. This is from a previous presentation that we've done, where we looked at different supply chain strategies. But the main thing that I'm trying to highlight from this is that you have on the top in green, and you have the installation window, which is we have taken as about 7 months. And then you have the different colours below are different components, essentially, where the mooring line can be considered as the steel chain. Then we have the connectors, the anchors, and the synthetic rope that might be used. And the main thing that we're trying to highlight from this is that the different batches will arrive at different times. And this is all about trying to understand that your different suppliers will have different capacities. And that is why one of the main takeaways from our previous presentation was that ability to act early on. And as you can see as well, you probably won't be the only one in the market. So we have just done a small example with the synthetic rope on the bottom, where it's booked out for the first 3 months, which has the resultant effect that the last batch 7, which is in the bottom right, arrives a bit later than anything else. So this is just a very simple example, but it's just to highlight the fact that when you try to plan things perfectly, it might not quite go, just due to the fact that each supplier will have their own capacity, which needs to be known early on. And then something that's worth considering for the marshalling port in terms of the storage is that you can see up the top left, the storage capacity is at 100%, so it's all available. And then if you fast forward to month 9, you can see that installation starts with the installation window, and the storage drops down to only being 40% available. However, that then is alleviated slightly as the installation starts, and it increases again to 60% with the installation at 50%. And then again, it drops as more batches of the steel chain and rope arrive. And the main takeaway from that is it will fluctuate depending on the installation windows and how much can be completed, as this will generally be a pre-installation. So the final takeaways is that a detailed strategy is required to align order dates and batch delivery dates. Individual component and suppliers' capacities will vary. The delivery of batches can be difficult to coordinate successfully, and a larger storage space helps to alleviate that logistical burden. But what does that look like in terms of numbers? So I've talked a lot about the challenge behind it, but in terms of trying to paint the picture numbers-wise, for a 180 megawatt storage requirement, you would be looking at, for the individual components combined, about 29,000 tons and about 21,000 meters squared storage area, which, to help visualize, is around 2 to 3 football fields. Which is good in talking about numbers and trying to imagine that it's a large site, but how would the layout look on such a site? Well, we also have a nice mock-up here, which is for 12 floaters, and the area shown here is 6.1 hectares, which is generally around, from looking at the Taiwan ports, which are very busy at the minute, but you'll be looking at, you would need around this size of site to operate things efficiently. So you can see on the left-hand side, you have the shanks, which are all separate individually, and then just below them is the flukes for the anchors. And then to the right of them, you have the steel chain, which is all in very neat little bundles. Whether it would be as perfect a layout as this is very much an example of how much area it would generally be required. And then up the top, you have the sheltered storage space, which is where the wheels are and the connectors are. And of course, there's the crane down the bottom, and you would need space for the forklifts, etc., to be able to move in between them. So there is still space there, but this is generally for a 180 demonstrator site. But if we were to then take a step up and look at the 510 megawatt storage site, again using DEAs, the total weight that you would be required to move would be around 82,000 tons, and the coupled storage area would be around 55,000 meters squared. And you can see quite easily it jumps up to about 7 to 8 football fields in terms of area. But again, the most interesting part is how would that then start to look if you were to lay it out. So on the same size of area, a 6.1 hectare site, you can see things are quite a bit tighter, and you can see the additional anchors and steel chain there. And something that is worth pointing out is that this is for 34 floaters. But that perfect representation of chain on the right-hand side, this would be the ideal scenario. But when you start to move things onto the vessel, for example, when you have done the first, say, 15 or 20 lines or batches, what would then happen is you then need to start to move the ones above closer to the quayside, which then becomes a bit more of an operational challenge, as the chain will generally move in smaller bundles individually, which can become quite a time-consuming process, which if there is multiple things going on, you really do need that detailed plan, and it's something that shouldn't be underestimated. And then lastly, just to give that additional example, the two previous ones were for drag embedment anchors. But as we discussed about drag embedment anchor being having a much smaller footprint, if we were to look at piles, however, the numbers would essentially jump up to, in terms of weight, you'd be looking at moving around 100,000 tons. And then you need a cumulative storage area of around 67,000 meters square. And then that's looking at, again, in terms of football fields to help you remember, you'd be around 9 or 10. And that's again mainly because they are being stored horizontally. So moving on to the key points now. Global capacity is increasing, resulting in a constricted supply chain. And my colleague Nathan shows some great graphs about when we start to hit that 2028 to 2030 period, demand really exceeds supply, which is why the early action is something that we are trying to really emphasize. Material security is vital in preventing delays and allowing fabrication to start ASAP. Diligent selection and fabrication yard can allow a reduction in cost, transportation, and greater control over the whole life cycle of a component. And this is something that we're really trying to highlight, that if you can reduce cost, a lot of cost models which are done early on tend to overlook these additional operational costs and logistics, which is something that we are trying to stress. As a lot of time when you might be early modeling things, you can look at the cost for individual components, but then you may overlook the likes of the cost for on site where you're moving things around with cranes, day rates, etc., and then also the required vessels for moving and transportation. The fabrication yard with access to a quayside and shipping lane enhances logistical movements, again helping reduce that burden. Quayside layout and storage must not be underestimated. Mooring design with drag anchors would require less storage space, and we had that example for the 510 megawatt Lake 2 project, which is essentially around the 20% reduction if you were to change from piles to drag embedment anchors. And that 20% reduction is for approximately both for the area and for the amount of tons you've been moving. And then last but not least is wanted to highlight the consideration of cost reduction in the logistical and storage requirements, as I've mentioned. But that was a fairly quick overview. Thank you very much for listening. And in terms of contacting us, please do reach out if you do have any other questions, or if you would like to have a copy of the slides. Thanks very much.
Thank you to both of our speakers for bringing us a splendid presentation. Thank you. Last but not least, we will hear from Mr. Mark Richmond, Senior Engineer and Project Manager of DNV. He will be focusing on the topic of enhancing Taiwan offshore wind resilience, project certification insights from the ACE-JIT project, and the future of floating. Welcome.
Hello, everyone. Thank you for having me on here today. I've had a slight title update. I'm now Taiwan Area Manager. It's an honor to be able to present to you today. Hopefully I'll meet you guys in person tomorrow if the weather allows. So as I said, I'm the Area Manager of Taiwan for DNV Renewable Certification. And today I'll be talking to you about, first of all, an introduction to DNV as a company and DNV Renewable Certification. Then I'll talk about our project certification generally and also our experience here in Taiwan. I'll talk about a summary of a very relevant joint industry project we worked on called ACE, which covers earthquakes and typhoons. Lastly, I'll cover certification of floating wind, our long experience here, and how we can bring this to help floating wind come to Taiwan. So first of all, some background for our company. We're a very old company. We recently celebrated our 160th birthday. We have over 13,000 employees, and we're in over 100 different countries. Here in Taiwan, DNV generally has an office in Taipei and Kaohsiung. Our certification office is in Taipei. An interesting figure from this slide is that we spend 5% of our revenue on research and development. This is for research projects, for joint industry projects. We write standards and technical notes, and these are things that we share with the industry to help support its growth. Our company started in shipping and offshore as a classification and advisory society. Then we grew into other markets, including energy. That's the part that I'm in now, in renewable certification. We've been in offshore wind pretty much as long as there has been an offshore wind industry, for over 30 years. And we're in other industries as well. We globally have certified over 130 offshore wind farms. It's something like 75% of all of the offshore wind farms in the world. In emerging markets, we've certified over 21. Many of these are in Taiwan, which I'll get onto later. We work directly with the project developers, project owners, the OEMs, and we work with the component manufacturers as well. So we've worked with pretty much everyone in the industry, and we have a good relationship with them. Every year, we release an energy transition outlook. This is our prediction of how the energy transition will grow into the future. And for fixed offshore wind and floating offshore wind, we foresee a large growth into the future. There's a small sliver on the top of this slide here, of this figure, which represents floating offshore wind. It may seem like a small sliver, but at 2050, this small amount would amount to 5,000 gigawatts of capacity. So definitely an industry to be a part of and to help grow forward. For the levelized cost of energy, recently we've seen a reversal in the levelized cost of energy due to COVID and the Ukraine war and other factors causing inflation and supply chain issues. It's unclear how long this reversal of cost will continue, but we foresee into the long term of 10, 20, or 30 years that actually will have a continued reduction in cost as technologies and supply chains mature. There's some capacity for this reduction in onshore and fixed offshore wind. This can be matured further, but the largest capacity for cost reduction we see as being in floating offshore wind, potentially with a reduction to 1/5 of what it is now. For our experience in project certification, DNV does type certification and project certification. We have been the project certification body for almost all of Taiwan's offshore wind farms. Of the 6 that have been connected to the grid, we have been the project certification body for 5 of those. And we're a PC body for all of the others. We've worked on Hailong, Zhongneng, Zhangfeng Xidao, Taipower, Yunlin, the Ørsted projects, Formosa 1, 3, 4, Haisha, Fengmiao, and the Weilanhai Jianghua project. So we've seen all of the potential challenges and pitfalls that projects can have, from the environmental conditions, from typhoon, seismic, soil conditions, design challenges. We've been involved in the construction phase and transport installation phase. We do workshop approval for the supply chain. So we have seen all of the potential challenges. We've also seen all of the successes in the industry, and we're very proud that we've been able to have some part in supporting that. So fundamentally, what is project certification? You could take a standard which defines how a project should be conducted, or the engineering that should be involved, and we compare this with the project itself, with the documentation provided by the project. You could have any standard. DNV writes several standards. There are other standards that we can certify to, as we are accredited by ISO 17065. We're one of the few certification bodies that can certify to OD 502. But what this is we provide a third-party attestation. What this means is, based on a review of the standard and the project, we attest that the project is in compliance with the standard, and we issue a certificate at the end, which can then be used to provide it to stakeholders to support the project. Why do projects seek project certification? In many markets, it's a regulatory requirement. In Taiwan, for example, it's a regulatory requirement that projects have project certification. There are markets where it's not a regulatory requirement, for example, the UK. Even in these markets, projects still seek project certification because of the other values that it provides. It mitigates the risk at effective stage. It can increase the confidence in the technical integrity and reliability. It can help the project developer ensure that their requirements are met. It supports supply chain and quality management. There are big financial benefits for doing it. It minimizes the financial risk. It can help in securing investment for the project. What we often see, for example, is that our design certification is a prerequisite for projects to achieve financial close. It can help ensure better insurance rates by showing the insurers that the project is conducted to a high standard, and as mentioned, help with authority approvals. In Taiwan, project certification is a regulatory requirement, and that regulatory requirement is set by BSMI. BSMI define the assets that need to be certified and the scope that they need to be certified to. They also define which standards need to be followed. For the current round of projects in 3.1 and 3.2, the turbine and support structure should be certified according on the design basis, design, manufacturing, and transport installation phases. It's also required that offshore cables and the offshore substation should also be certified, but to a lesser scope. To achieve the required certification, there are two main service specifications that can be followed, either OD 502 or DNV SE 0190. For achieving project certification, both are equally good, but there are benefits and negatives to both of these. DNV SE 0190, which we write, it covers more information on offshore cables and offshore substations, and it's a bit more flexible while also providing more guidance. So we tend to see this as being selected more often. Underneath the service specification, there are further technical standards to follow. As an example, DNV ST 0437, which covers the loads and site conditions for wind turbines. This was recently updated to incorporate typhoon and seismic effects. There's DNV ST 0145 for offshore substations. We also have recommended practices such as DNV RP 0585 covering the seismic design of power plants, which I'll get onto later. And we have many more. And this covers the scope of the project and certification for what the project is required to follow. The project certification follows a process as outlined here in this figure from DNV SE 0190. We subdivide the project into specific assets, which are the wind turbine and support structure, the offshore substation, the offshore power cables, which are the inter-array cables and export cables, and the control station. The project is then certified in phases, which are design basis, design, manufacturing, and transport installation, and sometimes commissioning and operations. When a phase for a given asset is completed, we will then issue a statement of compliance to state this. For example, when the wind turbine and support structures on a project fulfill all of the requirements within design basis, we'll issue an SOC covering the design basis of the wind turbine and support structure. So this ensures that the project receives deliverables throughout the project rather than having to wait at the very end. Now to discuss the ACE Joint Industry Project. This project came about because of challenges in new markets, which are not experienced so much in Europe. These challenges specifically in this project are earthquakes and typhoons. For earthquakes, there's uncertainty in design conditions, geotechnical conditions, and the combination of loads between wind and earthquake loads. There's inconsistency in how these design approaches are used. The international and local codes are maybe insufficient or not harmonized. In typhoons, there's large uncertainty in the extreme wind speed that can be experienced. There's uncertainty in transferring local building codes. Detailed models can be expensive and uncertain, and there's really a lack of measurement, particularly around Taiwan and other markets where there's not such a history of oil and gas, and so not many measurement stations that have been installed previously. So this becomes a bit of a challenge when trying to estimate long return period values. Many other companies saw this as a challenge and joined us on the Joint Industry Project. These are the ones you can see here. There are many well-known European companies and also some Taiwanese companies who all saw this as a real challenge. So thank you to all of you who took part. What we did on this, for the cyclone workstream, we conducted a critical review of available cyclone measurements and state-of-the-art modeling. We selected a few well-documented cases to conduct a case study. We benchmarked the models against each other, against measurements, and we quantified the strengths and weaknesses and limitations of these. This work resulted in a technical note, which was released. On the seismic workstream, we conducted quite a bit more work and accomplished some good results here. We conducted a summary of existing standards and methods. We addressed geotechnical challenges such as damping, liquefaction, and combination of time histories. We benchmarked different approaches. So here we used a independent structural analysis to compare time and frequency domain. We compared integrated compared to submodel approaches. We used different turbines and foundation types. And we calibrated and validated some simplified models to be used. This work resulted in a recommended practice called DNV RP 0585, which covers the seismic design for wind power plants. This recommended practice is changing the way that the industry conducts its seismic analysis and is used on pretty much all future projects that have seismic conditions. ACE1 was seen as a very large success, but the industry is still hungry for more information on this. So we are currently conducting ACE2, which is further details from the previous ACE1. This should be completed relatively soon, so look out for this. On floating offshore wind, we have a service specification called DNV SE0422, which covers the certification of offshore wind, floating offshore wind power plants. This recently had an update, which I'll talk about later, but it covers concept, basic design, project certification and class, and in-service. We see that many of our customers go for basic design, which is a more general type of certification, where the size of the turbine is known, but maybe the specific turbine isn't. So this is a fairly common service that we see. In terms of how we see project certification for offshore wind from a DNV perspective, at the top, we would still have this well-known DNV SE0190, which developers are used to, which is the project specification I mentioned earlier. Underneath all of this, we still have the technical requirements. DNV also has floating wind specific technical requirements, such as DNV ST0119. And between these, we have a new layer that could be either certification or a classification approach. These are slightly different. The certification approach, DNV SE0422, recently had an update where it allows for integration of a classification for the floating substructure. This is what we see as really the optimal solution. You could have the classification of the floating substructure, and then this is integrated like a type certificate into the certification approach. This is really the best of both worlds because shipyards are very familiar with and like working with the classification approach because it's well known to them, it's very prescriptive. But in the end, it's a wind farm project, so a certification approach works best here. This allows for the benefits of both to be integrated together. DNV has a very long history of offshore floating experience. We started with the high wind demo in 2009 and released the world's first guidance on this in 2009. Shortly afterwards, we released the world's first floating specific standard. We've been involved in many demonstration projects and other floating wind projects since then. We've been involved in a lot of joint industry projects, including offshore floating substations, joint industry project for cables, joint industry project for reliability and mooring. We're soon to start a ground investigation and floating wind turbines joint industry project, which I think would be particularly relevant for Taiwan. We have completed over 50 offshore wind floating projects in the world. We currently have ongoing between 15 and 20 floating wind projects, which are various stages from basic design all the way to full-scale commercial projects. Personally, I conducted the MetOcean review on one of these full-scale projects. So we have a very long experience of this that we're happy to share with the industry. Digging deeper into our service specification for DNV SE0422, there's a requirement for integrated load analysis. This is something that we see as very beneficial because unlike a oil and gas platform or some other fixed platform, you have a wind turbine on top, which has a very complex load behavior. To analyze this, we use a integrated load analysis. This is something that we do on all of our fixed bottom projects, and we see as particularly important for floating projects. This is where you have a coupled aeroservo hydroelastic model where the structure is modeled alongside the loads. So why would you have the loads and the structure modeled in the same approach? Well, when the loads are applied to the structure, for example, the wind acting on the blades, this causes a deformation of the structure. The blades might deform and the aerodynamic profile will change. There's also some controller action. If the wind speed increases or decreases, the controller will pitch the blades to account for this. So this needs to be modeled together as the two will influence each other. You have to include the environmental conditions, the controller, the turbine aeroelasticity, and in floating, there's more challenges to include in this. There's the mooring lines, there's the platform design, and all of this should be assessed with the design load cases. For floating, there are further additional challenges. There's more complex hydrodynamics, such as wave diffraction and coefficients need to come from tank tests. There's longer simulation times that are needed. For fixed bottom, we typically use 10 minutes. For floating, we typically use 1 to 3 hours due to the movement of the platform. There are additional cases to consider, such as a robustness check, with a high return period, such as 500 years. There are additional failure cases to be considered, such as the loss of mooring lines, and there's further stability analysis that needs to be performed. Some learning outcomes from our long experience in floating. The project should be considered as more than just a single floating structure, which may have some similarity to a floating oil and gas platform. Instead, it should be considered as an energy system combined with the environmental effects, the wind turbine, the cables, and other aspects, because in the end, it's an energy system with the goal of delivering power to the shore. So in the end, to summarize, DNV is a highly experienced project certification body leading globally and leading in Taiwan. We conduct many joint industry projects. One of these of note is the ACE JIP with the resulting DNV RP0585, which has changed the way typhoons and seismic are conducted in the industry. And DNV is also the leading certification body in floating. We've conducted more than 50 projects worldwide. We're currently conducting between 15 and 20. We're highly experienced here. We had the first floating certification standards, and we issue more wind-specific floating standards. And we are looking forward to supporting the Taiwan industry with coming floating demonstrator projects and more into the future. So thank you very much. This concludes my presentation. Please feel free to email me if you have any questions. Hopefully I'll be around at the Energy Taiwan exhibit tomorrow, and then you can talk to me in person. Thank you very much.
Thank you, Mr. Richmond, for your valuable insights. Thank you. Once again, thank you to all of our speakers and guests for their participation and contribution. Thank you. 再次感谢所有讲师，希望今天的讨论能为台湾离岸风电产业的发展带来新的启发和合作机会，并为台湾产业注入强大的动能。也再一次感谢协办单位欧洲在台商务协会的协办。另外，也要特别感谢支持单位及赞助单位东方风能、DNV、Mooreast 及天丰新能源。CEMI长期关注全球永续发展以及气候变迁所带来的挑战。为响应联合国永续发展目标，我们透过 CEMI Forest 这项计划在全球植树造林。主办单位 CEMI GSA 在展览期间与讲师们携手推动绿能发展，也为所有的讲师透过这个全球性平台种树减碳。我们诚挚地邀请在线上的各位共同参与 CEMI Taiwan Forest 植树计划，一起为全球永续尽一份心力。各位贵宾，台湾离岸风电竞争力高峰论坛在这里告一个圆满的段落。非常感谢您今日的参与。Ladies and gentlemen, our forum has come to an end. Thank you so much for all of your participation. 在前方萤幕上有一 QR code 问卷，填写完问卷者，主办单位将于2周后提供讲师授权之简报及后续主办单位上传影片至 Semi YouTube 的连结，邀请大家踊跃填写。再次感谢大家的热情参与，祝福各位都有非常美好的一天，谢谢。